Big data engineers are in demand. But before jumping directly into learning any big data tool or technology, you first need to master and learn the fundamentals such as what is big data and 3 V's of big data, data lakes and data warehouses, evolution of Lakehouse, ETL and ELT, Medallion Architecture, big data file formats, big data processing, Hadoop MapReduce, Apache Spark fundamentals, what is Databricks, Delta Lake architecture, Apache Airflow tutorial with DAX, cloud data engineering, real-time data engineering with Kafka, Apache Spark architecture, RDDs. But why learning and mastering fundamentals are so important? Because let's say you have started learning a tool and in the middle of that you got the questions. Hey, what is Delta Lake? Hey, what is Apache Airflow? Hey, what is Spark architecture? Hey, what is RDDs? And so many other questions. So you will be blocked and stuck. So you first need to build that backbone of big data engineering, which is the fundamental. So that is why I decided to just create this masterclass on big data engineering fundamentals. After getting a great response on my previous video, which was for data engineering fundamentals, I decided to create a dedicated video on big data engineering because big data engineering is growing rapidly, and this video is strictly aligned to modern big data engineering tools and technologies. The best thing, there is no prerequisite, literally zero experience required. Everything will be covered from scratch, and the best thing, notes will be provided throughout the video, plus all the free resources will be provided to master each and every technology in depth. So without thinking much, let's get started with this amazing master. So what's up my fam? Happy Sunday. And this Sunday is very special because this Sunday we're gonna talk about big data engineering, which is one of the most in demand topics right now in the industry. Everywhere you go, you see big data tech stack. Even if it is data engineering, data analytics, data science, machine learning, AI engineering, everyone is talking about big data. That is why this video is here. And what is the agenda of this video? What is the agenda like? What is the big picture of this video? This video will not make you a pro big data engineer. No. But you would have heard about some terms, some jargons, some keywords which are you totally unaware of. Because currently, let's say there's a person X wants to learn about big data engineering. He or she will directly jump on to learning Apache Spark without even knowing what is the need of learning Apache Spark. Then the person will directly jump on learning Databricks without even understanding the need for Databricks. So this particular big data engineering masterclass, basically this is a fundamentals masterclass, will build your fundamental knowledge about all those terms, technologies, tools, everything. Because after watching this big data engineering masterclass, which is a fundamental video, you will have clear understanding about these terms and technologies, and you will be able to learn and master any technology. Plus, in this particular masterclass, I will provide you the best resources for free. Best resources from where you can master each and every single technology in depth. So this is a complete package. So let's start with what you will master. You will first of all master these terms and technologies. What is big data, 3V's of big data, ELT, Medallion Architecture, Data Lakes, Lakehouse, distributed computing, Apache Hadoop, Apache Spark, RDDs, Apache Airflow, Databricks, Azure Data Factory, Apache Kafka, real-time processing, literally everything. You will understand each and everything, and after completing this video, you will be like, okay, now I understand big data engineering. Now I understand what is Apache Spark. Now I understand what is Apache Airflow. What is Apache Hadoop. Now, if I want to master any specific technology, for example, Databricks, let's master it because now it will make sense. And from where to master Databricks? Resources will be provided in the video. I hope you are clear with the agenda of this video. The purpose of this video is just to make you aware and make you understand the concepts, tools, technologies, terms, architectures of big data. Do not directly jump on learning the tool and technology. No, first of all, understand the fundamentals, basics. Now I have already created a detailed data engineering fundamentals video, which is like data engineering fundamentals, but this is completely aligned towards big data engineering. And this is the need of the hour. That is why I created this video, because the last video I created, I think last year, approximately 11 months to 12 months ago. This is completely focused on big data. Make sense? And are you excited? Just take out your notebook, because there's so much to note down and you will be required to note down so many things. Okay, so let's get started with our amazing master. And before that, let's first of all congratulate our really dedicated people who just cracked the offer letters more recently. Okay, so I just try to congratulate these people and I want to see your name as well very soon. Okay, how you can just be here? Just follow the guidelines, just follow this particular channel. These people have done exactly the same. Congratulations to all of you, and I'm really happy for you. And there are more people, and there are more people, and there are more people. So first of all, congratulations. If I miss your name, so sorry about that. So these are basically the more recent offer letters that are being cracked by my lovely fam. And you know what? They didn't go here and there. They didn't just follow the guidelines like what others are saying. This person is saying, hey, this content is not good. Hey, this person is saying, hey, that content is not good. No, just sit back and relax and just watch the tutorials, just go through the videos, just gain the knowledge, and that's it. No if and no but. Okay, make sense? And there are a few more people. Okay, and these are my handles that you can just follow me. Okay, so now let's get started finally. So let's get started with our first question, and I think this should be your question as well, because it's my personal advice. Whenever you're learning something new, always try to understand the concept first of all, because in our domain most of the concepts will be clear if you understand the keyword, if you understand the, you can say, behavior of that keyword, like what it is trying to say. Make sense? So obviously this is a kind of big data engineer fundamentals masterclass, and I have already mentioned like we'll be just covering all the fundamentals. And yes, I remember like I'll be providing you the detailed resources as well. All are free, okay, to just master each and individual framework, tool, technology, everything. But even before that, you should ask this question: what is big data? What is big data? If I ask you this question, what is big data? No judgments. You just need to be honest and just try to answer this question in one line instantly. Okay, I know you have done that. I know you would have said something. I know that. But let's see how accurate you were. Big data is something related to data, first of all. Okay, big data means we are talking about data. And data is big in size. It is called big data. Were you close with this definition? If yes, then very good. You have some understanding like what you are trying to learn. Okay, makes sense. But you know what? This sounds very simple. Big data is like data, but with much bigger size. That's it. This is big data. Not really. Not really. This is just like one part of it. There are multiple parts of it. Make sense? Multiple. So big data. Word is very fancy, I know. Very fancy. I also love this word, big data. And let me just tell you, with the course of time, and this has started more recently as well, big data is actually renamed as data. Oh, but why? Because initially when this field was new, like very new, then people used to say you are a data engineer and you are a big data engineer. But currently when you say you are a data engineer, then they assume that you are a big data engineer as well. That is why whenever you go to any job portal, let's say LinkedIn, anywhere, and you want to become a big data engineer because you want to land a job for a big data engineer, right? Or let's say data engineer. Let's start with data engineer. Let's say you want to land a job as a data engineer and you just clicked on the job description and you just started reading it. You realized, bro, I just want to land a job as a data engineer, but why the job description is full of big data technologies, big data frameworks, big data tools? Why? There is nothing mentioned related to big data in the title. But why is it so? This is the reason. Because currently they know that big data is not a wow thing. Big data is not a, let's say, a distinct thing. No, it is now the day-to-day thing. So they know when we are talking about data, we are talking about big data. Wow, this was new. I know that, but this will change your mindset. Now, if you are coming from, let's say, analytics background, if you are coming from a data science background, machine learning background, there also we just work with data. This same law or basically process gets applied there as well. Why? Earlier they were data analyst. Earlier they were data scientist, right? Now they assume that you know the fundamentals of big data because you will not be working with small size data sets. You will be working with big data sets. And when you just want to work with a big data, they are not saying like you need to become a big data engineer even if you're a data analyst. No, I'm not saying this. I am saying this even if you are a data analyst, data scientist, machine learning engineer, anyone who is working with data. You need to understand the concepts of big data because data is now being understood as big data in all the domains, not just data engineering. So this is the first thing that you need to focus. Okay. Makes sense. So that means big data is for everyone. Yes. Earlier, big data was for just data engineers, but now big data is for every single professional who is working with data, who is into this field. They will not ask you to build end-to-end things. No, but you will be working with those technologies as well, right? So this particular masterclass is, yes, obviously for big data engineers, but it is also for anyone who want to become a data professional in today's era, in 2025, in 2026, and obviously in 2027. So I can say that this masterclass is for everyone. So if you have any friends who are also in the data domain, just try to help them by sharing this YouTube video with them. Make sense? So this was all about the big data jargon that we used to hear a lot. And I hope it makes sense like why it is so important right now to learn about big data, because right now, October 2025, this is the, you can say, need. Earlier it was good to have, now must have. You cannot negotiate with it. Must have. Okay, makes sense? Very good. So this was all about big data, like what is actually the big data. Now you will say, Ansh, Lamba, we understood the concept that data is growing rapidly and all those things, but what are the problems with big data? What are the problems with big data? If data size is growing, why do we need to worry? Makes sense. This is a valid question. What are the problems with big data? Okay, earlier, let's say we were just processing 1 GB of data. Now, what's the problem to process 1 terabyte of data? Whoa, what's the problem? Like, I don't understand why people are making noise. So you will understand it very, very soon. But before even talking about problems, I want to take you back to talk about what are the sources of big data. Why big data is being generated? Why? So the answer is you. You are generating big data. Ansh, Lamba, I hardly write one line of message to my closest friend. How I'm just generating big data? So even if you are not generating data, you are also generating the data. What is this? So let me just tell you. Let's say this is you. Okay. Let's say this is you and you are using your mobile phone. Make sense? You are watching something, let's say, of your favorite. Let's say you are watching a tutorial. Okay. Anything. So you are actually generating the data. You will say, Ansh, Lamba, are you serious? I'm literally just watching a video. I am just watching a video. Let's say I am just watching any video. I am just consuming the content. How I am generating the big data? So the data is this person name. Let's say your name is let's say Priya. Oh man, I need to see, because I am receiving some comments like, why do you use the same name again and again? Who is Priya? Who is Priya? I don't know who is Priya. So let's take a new name. Let's take the name Kapil. Okay, let's say you are Kapil. Okay, makes sense. So you are Kapil. This person is watching a video, let's say called Big Data Fundamentals. Big Data Fundamentals. Okay, this person has watched, let's say, 1 hour of content. This person has liked the video, obviously, because you have liked the video. And if you have not, just hit the like button right now, bro. I'm just putting so much of efforts just to make you understand all these things. Just hit the like button. What are you doing? Okay, like the video. This person has commented on the video. You need to comment down as well. This person has subscribed the channel. Makes sense. Okay, just do it everything right now, because then only you will be able to relate to it. Trust me. Okay, so let's say you have done all these steps. Just do it right now quickly. Okay, so all of this data is actually generated. Oh, yes, you have literally generated the data right now. Right now, you generated this data. Okay, so I hope now you're getting the vibe. How is big data being generated? Literally from everything. You are watching a video, data is being generated because your information, videos information, it's called metadata. It's called metadata. If you are not aware about this term, metadata, it's called metadata. Metadata means information about data. So data here is obviously this video. And what is the information about this video? What is the title of this video? What is the length of this video? All of these things. So these are the information, right? So info about data. Info about data. So all of the metadata, all of your detail, everything is generating the data. So just imagine, like you, there are so many individuals, there are so many videos, there are so many things. So everything is now being accumulated and generating the data. Wow, literally wow. This is just one example. Let's suppose you are just scrolling your phone and you are literally, let's say, scrolling LinkedIn. Okay, or any social platform. You are liking the post, you are commenting, you're sharing, you are maybe posting something. Everything is generating data. Let's say you are purchasing anything on, let's say, Amazon, right? Let's say you are just purchasing your favorite mobile phone, anything. You are generating data there as well. Or let's say you are just simply Googling it. You are simply, let's say, checking today's weather. You are generating the data that this person has just checked this weather right now. And what was the location and everything. Obviously, if you have allowed the location, otherwise it will not track it. But there are some things that you need to just relate to. That everything is contributing towards generating the data. So in short, with the rise in internet, this data, which was like this before internet, not even about like before internet, I would say now more and more people are exposed to web pages, websites, and all those things. I would say with the growth in internet, okay, more consumers of internet. So let's say this was the data before. Now this data has become this data, and even bigger than this, because my screen size is small right now. So yeah, wow. So this data has actually become this data, and it is growing exponentially. Why? More and more people are engaging with the content, more and more people buying some things, more and more people exploring something. So actually this is a kind of revolution. Okay, makes sense. And do you know what? You will see, you will say that, Ansh, Lamba, do you know what? we literally didn't feel like this because we were just living our life normally, and we literally didn't hear anything in the news that data is growing, that data is bursting, that we cannot store the data. All thanks to the people, to the community who actively worked on developing those frameworks, developing those strategies which were able to handle big data. Otherwise, it would be a mess. Make sense? So say thanks to all those people. Make sense? Okay. And you will learn about all those things. And I hope now you will be very, very interested to know all about these things, right? Because now you want to know how to process these things, how to store these things, how to manage these things, how to upscale these things. So now I know you have that particular vibe. And you can say thanks to me for generating that vibe. And yeah, okay. So now let's talk about what are the problems with big data. Let's say this data size is grown to this much. Okay, Anshulamba, we know that. But bro, what is the problem? What is the problem? So now let's talk about problems with big data. You will say, Anshulamba, okay, let's say I have a computer, okay, and I was storing, let's say, 1 GB of data before, and now I know that this data size is grown to let's say 100 GB. Okay, let's say 100 GB. So what is the problem? I can increase the storage capacity of my computer, right? So what is the big deal? Why people are making so much of noise, including you? Why? So big data actually started growing. What do you mean? Earlier, big data was only about the volume of data. It was all about volume, like data size has grown 1 GB to 10 GB, 10 GB to 100 GB, 100 GB to 1 terabyte, 1 terabyte to 1 petabyte, 1 petabyte to 1 hexabyte, 1 hexabyte to, I don't know, just check it on Google. Okay, so it was just about volume. So your question is right. Okay, we can just increase the storage, right? But you know what? There was one more problem. What? Velocity. What is this? We are not studying here physics, bro. This is not physics. Velocity, or you can say speed. Okay, and if you are coming from physics background, you should know the difference between both velocity and speed. Velocity is just speed but with direction. Okay, this is not a physics masterclass, so for technique, for computer domain, for data engineering domain, velocity and speed both are same. Okay, so okay, that means big data actually was growing with great speed. You got it right. So what was the thing? Yes, we were able to see a great volume of data, but with a great speed as well. That means, okay, today you have 1 GB of data, okay, and after a month, it was 10 GB of data. But after just one more week, it grew from 10 GB to 100 GB. And after 1 to 2 more days, it grew from 100 GB to 1 terabyte. So people identified this problem, bro. Data size is also like only data size is not the problem. It is the speed as well. It is growing so rapidly. We cannot upscale our storage so quick. Makes sense. Then another thing. What? Then we also saw one more problem. It's called variety. Okay, what do you mean by variety? For example, so far we were only getting data in the structured format. Structured format as in the tabular format. Let's say you are getting the data in the tabular format like this, where data is well structured in the form of rows and columns. If you have used Excel sheet, you can relate to it, right? Where data is actually structured. But we started getting a lot of variety of data. We started getting images, videos, text files, PDFs, all those things which were not being used before. So now data was not just about tabular data. It was not just about structured data. It was also about semi-structured and unstructured data as well. Okay, semi-structured and unstructured data as well. Makes sense. Now, what is semi-structured data? Because we understood structured data, tabular format. We understood unstructured data, that means which doesn't have any kind of structure. For example, images, videos, right? But what is semi-structured? What is this? Basically, semi-structured data means it has some structure, but it can change. Let me repeat again. It has a structure, but it can change. For example, JSON. So when we just work with JSON, you would have seen JSON. Okay, JSON is JavaScript object notations. So whenever you see data like this, let's say in the curly braces, and you see key, and you see value, and then so on, right? So this is JSON data. So JSON data doesn't have any kind of structure, but it has a predictable structure, not a fixed structure, predictable structure, where yes, new columns, rows can be added, but we still have some idea, right? Like how structure will look like. So it is called semi-structured data. Make sense? It doesn't have the fixed structure, but we have some idea. Makes sense. So you will say, okay, now we know like these three V's are the problem: volume, velocity, and variety. Yes. So this is a concept called 3 V's of big data, which gave rise to big data solutions, technologies, frameworks that we'll be just learning about. Okay. So this was the concept, 3 V's of big data. But you know what? With the course of time, it has become, I think, 6 V's, or I would say 9 V's. You can simply Google and you can simply search what are the latest V's of big data, because big data industry is actually growing rapidly. One I would know, it is called veracity. Veracity is nothing but, you can say, it has become, data has become less trustworthy, because data is being generated from everything. So you cannot actually trust that data. Veracity is there, and I think 2 V's more are there. So you can literally search, and let me just search it right now. You can actually do it. It's just a fun thing. But main 3 V's are these that you should know. And obviously in the market, there will be a new V every single, you can say, year. Or let me just search what are the latest V's. Latest V's of big data. Let's see. Oh, so currently there are 7 V's. Okay. So they have volume, velocity, variety, and veracity. Veracity is like, let's say, when you cannot trust the data, or basically accuracy of the data. And then value. Is that data valuable? Is that data non-valuable? Because you cannot actually see, or you cannot actually directly use it, because you do not know, like, is that data is of some value or not, or is it just the garbage data, right? So these are 5 V's for so far. And let me just read another blog, because they are just saying 7 V's. Oh, so 2 more V's: visualization and variability. Okay, variability is like similar to variety, but yeah, they have just made a dedicated category for that, variability. Basically, I know why they have created a different category of variability, because variability means within a single variety, you can evolve the data. But again, let me just be very honest with you, bro. These are the 3 V's that you need to understand. These are the 3 V's that you need to know. There will be a new V every single year, or there'll be new V according to much popular blogs. But you need to know about these 3 V's. Make sense? So these are the problems with big data. It's not just about volume. It's not just about data size. And bro, let me just tell you, even if it is just about volume, it's not very easy to work with big data. Okay, so we just understood the problems with big data. Now, let's talk about data storage. Ansh, Lamba. We know that we store the data. Yes. But before big data, how we were storing the data, and after big data, how we are storing the data, and where we are storing the data. That's a very cool thing that you need to know. Okay, because so far you have just learned about problems with big data. Okay, now you need to know the storage, because problem is there. Really, not complete problem, but yeah, some problems are there as well. So first of all, in order to understand this concept, you need to completely understand the data storage evolution. Data storage evolution. And trust me, you would have read so many blogs, you would have read so many things, I don't know. But this section, this small section, let's say 5-10 minute section of this particular complete masterclass will help you understand all the things that you need to know for data storage evolution. And you will love this, literally love this. Okay, let's start. So basically, data storage evolution, everything for data engineers, okay? Because data storage has been there for, let's say, almost more than 100 years. But we are just talking about data engineering data storage, the data that we are using to engineer our things, engineer our models, right? So in 1980s, okay, 1980s, okay, and I was, I think, minus 20 years old at that time, okay. In 1980s, Ansh Lamba, you were minus 20 years old. Okay. So they used to, okay, I am also the part of this community. So I was just planning to store the data in the future at that time. So in 1980s, we were storing the data in something called as databases. Okay. You would have heard the concept called SQL databases. Have you heard that? Like SQL databases. Okay. SQL databases can be, let's say, MS SQL. If you have heard, okay. And if you have not heard, I don't know what you are doing. Okay. So let's say MySQL, MS SQL, PostgreSQL. Okay. So these are the SQL databases that people, Oracle, so many, right? So SQL databases was the first choice to store our data, because in 1980s, we were not actually getting the data in the big data format. It was like normal data. Okay. 1980s was the era with the normal data. Let me just write it for you. And don't worry, all these slides will be available to you in my GitHub repo in the form of notes. But all these things that I'm just drawing and writing live, you need to write it on your own, maybe in your notebooks or in the blank space that will be here. Why? Because when you will be writing the same thing, you will remember it. Okay, so that is why I am not just copy pasting the content from Google and just telling you the definition and video is completed. Wow, no. You need to understand the concept. So I'm just teaching you in the form of a kind of live classroom, and you need to take notes as you go along this video. Make sense? Very good. So in 1980s, when it was like normal data, I'm not writing small data, normal data. Okay, so we were just storing our data in the form of databases. Make sense? And we were following a data modeling strategy which was called as dimensional data modeling. Make sense? Make sense? This is one of the best data modeling technique that we follow. Okay. And yes, I do have a dedicated video on dimensional data modeling as well, but you do not need to worry, because what I will do for this particular masterclass, at the end of this video, I will just dedicate, let's say, 1 to 2 minutes, and I will list all the resources with all the videos, everything there, so that you can just watch step by step. Make sense? At the end of this video. Okay. So just go through this video without jumping here and there, and at the end of this video you will find all the resources for dimensional data modeling, for big data modeling, and for Delta Lake, all the things. Okay. But yes, you can just write it down in your notebook that we will get the resource for this as well, or you do not need to do that, because you can just see the resource at the end as well. Choice is yours. Okay. I will not repeat this thing. So just make sure whenever I will say that I have a dedicated resource on that as well, that means that resource will be available at the end of this video. Make sense? Because I don't want to click on the link right away and just jump on the other video. You need to focus here. Make sense? Good. So dimensional data modeling was the technique that we used to follow in 1980s, and it was called as data warehousing. Oh, so this is the name of the strategy. Yes, data warehousing. So this is a kind of interchangeable word, data warehousing on dimensional data modeling. Makes sense? Because this was the modeling technique that was specifically built for data engineers, and we used to call it as a data warehouse. Okay. Makes sense? All these concepts are clear regarding databases, modeling, data warehousing. Make sense? So people ask me, hey, what is the difference between database and data warehouse? Actually, storage wise, nothing. It's just about how you store the data. When we just store the data in the databases with this modeling, it becomes data warehouse. Okay. When we store data in the database with normal, you can say data modeling, which is called normalization, it stays as database. It is not a data warehouse. Make sense? Okay. So this was the thing started in 1980s, and it was built by Ralph Kimball, and he just came up with this particular data modeling technique. Makes sense. Then it was working fine till early 2000s, like for let's say 20 years. Then I was born. Okay. Then industry started seeing a gap. What was the gap? With the previous technique, they were not able to handle the size of the data, because in this era, which started in the early 2000s, okay, let's say 2000s, okay, in the early 2000s, big data was started. Big data started. Okay, big data started. The era of big data actually started. So they were saying, bro, we cannot store our data because volume of data is growing rapidly. You will say, what is the problem? If the volume of data is growing, you can store your data in the SQL database and there will be like more number of records. What's the big deal? The big deal is cost, performance, and all those things. Okay. When data started growing, the cost associated to maintain those SQL servers was started growing as well, because it is not very cheap to maintain or scale the SQL servers. You need to pay for the compute, right? Makes sense. Then it was not very much performant as well, because SQL servers, I know, like can handle a lot of transactions, but for the writes, not for the reads. But when we just create a data warehouse, we want to read the data from that. Okay, that is also one thing. And there were so many problems. So they said, bro, we cannot store our data in the database. Okay, it is very expensive. Let's create something else. Then we came up with the concept called data lake. Okay, data lake. So what is this concept, data lake? What is this thing? Data lake is a concept, and it was a revolutionary concept. Why? Because it actually solved 3 V's problem. Remember 3 V's? Yes, it solved it. How? First thing, in the data lake, you can store so much of data at cheap cost. You do not need to pay much. Storage is so cheap. So that means first V is solved, that is volume. Perfect. Then you can store the data rapidly. Like you can just simply add as much as data that you can, and there's no performance thing, no performance issue and all, nothing. Okay, velocity is solved. Variety, it is also solved. Really? Yes, you can store literally any data in the data lake. You can store you can say images, videos, PDFs, structured data, semi-structured data, JSON files, anything, literally anything. So this problem is solved. Okay, so 3 V's problem was solved with data lake, and data lake was cheap as well. So now what is data lake? Basically data lake is built on top of your blob storage, and blob storage is built on top of block storage. Block storage is nothing but your, you can say, file system that you have in your machine. Okay, then blob is actually, you can just read some blogs. I know blogs. Like what is the difference between block storage and blob storage? It is not directly relevant to your journey, but it is good to have that particular knowledge. Just give it a read, so that whenever someone is talking about and using those terms, you will feel relevant. You will not be feeling lost. Make sense? So data lake is actually built on top of blob storage. Okay, makes sense. Now data lake means you can store any data in your folders. Okay, let's say you in your machine create a folder, okay, and you save, let's say, a file, and then you save images, then you save PDF. Now everything can be stored at one place and it is referred to as data lake. Not your personal machine. I'm just giving an example so that you can just understand it. Make sense? Makes sense. That is why you are seeing the concept of data lake nowadays, that we have data lakes in cloud platforms such as Azure, AWS, Google, GCP, right? You hear about Azure Storage Blob, and then you also hear about Azure Data Lake Storage Gen 2. You hear about S3 buckets. All are cloud hosted data lakes. Make sense? And when the data lake is on your machine, it is like on-prem data lake. But usually we do not create on-prem data lakes. We just go with the cloud data lakes. Yes, we wanna cover about cloud data engineering and cloud big data tools as well. Don't worry about that for now. But I'm just giving you some hints, right? Because it is important to understand the concept. So this is for data lake. Makes sense. So okay, now finally problem is solved, right? We can say like we are good. Now, why? What's the problem now? What is the problem? Problem is, let me just tell you. So the thing is, everything was fine. Everything was fine. With data lake, everyone was happy. So as you know, being a data engineer, you have two major stakeholders. Major. One is data analyst. Okay. Who will build Power BI reports, who will analyze the data. And second one is data scientist, who doesn't need any kind of structured data. They just need the files and all. So as you know, like data lake was able to handle all the file formats. Makes sense. So this team was really happy. This team was happy, data scientist, because they do not need to use any refined data, curated data, cleaned data. They just want the data. That's it. And they just do it everything on their own because they just build models, and every model is like unique. They do not need any kind of specific data. But with the data analytics team, they build reports, right? They build reports. And you know that whenever you want to build a report, you need a data model for better joins, for better relationships between the tables, for better all those performance, right? So with the data lake, that part was missing. That part was missing. Why? Because yes, data was there, but it was not in the form of a data model. It was not ready for data modeling because it didn't have those traditional, you can say, capabilities, or basically database capabilities. Okay. It didn't have the traditional database capabilities. Now, what are traditional database capabilities? Those indexes, constraints, primary keys, all those things were missing. All those things were missing. It was just about data. That's it. No schema enforcement, no about like nothing. All those things are very important for performance. But they didn't realize at that time when they created this data lake. When this team started complaining, bro, what are you doing? Our dashboard is not refreshing on time. What are you doing? We do not want your data. So what they started doing, they switched back to the previous method, which was data warehousing. Now, data lake was in the middle. It actually solved the problems, but it was not actually serving this team very well. Now, finally, this problem is solved. Really? Yeah. To some extent, yes. And obviously, it is improving as well. So now we have a solution which is called, any guesses? You can just let me know in the comment section as well. The solution is called Lakehouse. Lakehouse is nothing but the combination of both the words, data warehouse plus data lake. Okay, so house from warehouse, lake from data lake, Lakehouse. So this is the concept of Lakehouse. So now what is the concept? By the way, I was, I think, 10 years old when it was started. I think in early, wait. In the early 2000s, data lake was started. Lakehouse concept is like very young, and I can relate to it very well because I was around 20 years old at that time, and it started in 2020s. Okay, Lakehouse, and data lake was started in early 2000, around 2010 or 2007, 8, like this. Okay, so this is like my kind of thing, like my generation thing. Okay, because I can relate to it, like what actually happened. So Lakehouse is like data warehouse plus data lake. So what is the concept? Like what is this thing? I know like this word is very cool, data lakehouse, but what actually is the thing? So remember, data lake was able to solve the problem. Yes. So data lake was able to solve the problem, and we know that data will be sitting in the terms in the form of folders like this. Let's say one folder, second folder, third folder. Okay. Now you know that we want to include traditional database capabilities or slash data warehousing capabilities, where we can just specify the indexes, we specify the constraints, we specify the keys, we specify all those things, right? Yes. So what we did, we simply merged data warehousing capabilities. Now, how did we merge data warehousing capabilities? How? Because our data is sitting in the folders, that is for sure. That is for sure. Data is sitting in the folders. And you are saying that you have added this capability, like how? How? Because here comes the concept of open table format. Okay. Do you know what? I'm really happy for you, because now you are understanding all those jargons which were so popular, which you were seeing almost everywhere on LinkedIn, on blogs, on Medium, on videos, everywhere. But you are not actually aware of these things. But now you are aware of all these things, and now you can confidently talk to people. Open table format. I know this, bro, because I have watched Ansh Lamba's video. Okay, so I know very well what you're talking about. So yeah, this is the reality, bro. So open table format. By the way, don't behave like this, but yeah, behave maturely that you know the concepts. So open table format, it says, I will provide you all those capabilities, all those things, all those data warehousing capabilities on top of folders. And it sounds like magic, right? It's a kind of magic, but it is a kind of, you can say, revolution in the data engineering domain, in the big data domain. Make sense? Make sense? Make sense? I hope it makes sense. So how it provided these capabilities? Here we have three big players of open table formats. The first one, and the very popular one, and my personal favorite, Delta Lake. Delta Lake. Okay, Delta Lake or Delta format. Makes sense. The second player, which I like, okay, it is called Apache Iceberg. And there's third one as well. It is called Apache Hudi. So these are the top three open table formats. When we combine any one of these three formats, our data lake becomes Lakehouse. How? Because it adds data warehousing capabilities on top of our data lake. This is the concept of Lakehouse, and this is the thing that we are following right now. And it is working absolutely perfect, because these open table formats are actually becoming revolutionary with the course of time. Like literally, and this is the one. This is the most mature open table format, Delta Lake. It was developed by Databricks. It is, I would say, the most mature and amazing open table format. I can say that it sometimes gives you the better performance, better data warehousing performance as compared to a traditional data warehouse. So you can see you can just imagine the performance. Okay. And with the course of time, they're just doing amazing additions. Okay. So I am a big fan of this. So this is the evolution. So now our big data is being resided in the Lakehouse. I hope it makes sense. Very good. Now let's jump on to the next chapter. Then now here comes the question, which is a different chapter in itself: how to store big data. You will say, upload the file, upload the data, it is saved. No. Jokes apart, there's a process, there's a technique, there's a strategy behind storing the big data. Because if you have some understanding in the data engineering fundamentals, okay, because I have already created the video called Data Engineering Fundamentals, where I have generally talked about data engineering, okay, and there we always talk about something called as ETL. If you are familiar with that, ETL, which is nothing but extract, transform, load. But you know what? We do not use this in big data. Really? Yeah, we do not use this because it is not performant enough with the big data. Yes, if the data size is not too much, we simply go with ETL, but this is not the practice we follow with big data. Okay, that's why I have created this special video on big data, because we'll be only talking about big data. Okay, so in big data, we have a different approach, which is a little bit similar to ETL, but different in so many areas, basically in so many use cases. It is called any guesses? It is called ELT. Okay, and it says extract, load, and then transform. Ansh, Lamba. The previous technique was extract, transform, load. Now it is extract, load, transform. Like, what is this? What is this? Let me just explain you the whole architecture. Not architecture, the whole process. So let's say there is a source. Okay, there is a source. Source can be, let's say, anything. Literally can be anything. It can be your database. It can be your API. It can be your literally anything. Okay, local file, anything. This is a source. Okay, this is a source. Okay, and we basically, you as a data engineer need to load this data, okay, into a destination basically. Okay, and you were performing something called as transformations before loading the data. That is called ETL, where you simply first of all extract the data like this. Let's say you extracted this data. Okay, then you transform that data, then you, let's say, loaded data here. So this was the traditional technique. Makes sense. Extract, transform, load. Now with big data, yes, we can extract the data, obviously, not a big deal, but before loading the data, we cannot transform it. Why? No, we cannot. It makes the process very slow. Why? Because data size is big. If we will be performing transformations before loading, and transformation step is the most, you can say, heaviest step in the whole process, where we need to clean the data, transform the data as per the requirements. So this is the most heaviest task, right? We cannot perform it before loading. No, not at all. Not at all. So we reshuffled this process. Process is same. We simply reshuffled it. We simply said, bro, we will extract the data for sure, and we immediately load the data immediately without any transformation. I know there'll be so many garbage, so many, you can say, garbage data in that particular source, nulls, then you can say so many duplicates, so many garbage data, right? But we do not care. We load the data as it is. Why? It will be so quick. Extract and load, extract and load, extract and load. Simple. Lift and shift, lift and shift, lift and shift. Once the data is loaded, okay, then transform it as per your requirements. Oh, makes sense. Then you can transform it as per your requirement. This makes the process very easy. Why? Because whenever you are extracting the data from the source, you are actually putting pressure or load. No, load doesn't mean like loading. Load means, you can say, pressure on source, because you are using their compute sources, right? So here, when you simply extracting the data, you are not taking much time. Why? Because you are not performing transformation before loading. You are simply extracting the data and immediately loading the data. Immediately. No pressure, or you can say less pressure. Once the data is loaded, then you can perform transformation. Now A very smart student can ask this question, bro, at the end of the day, we need to apply transformation. So obviously sooner or later, pressure will be there. Very smart question. But now the thing is, pressure will not be on the source engines. Now it will be on the our side. It will be on our engines. So we have special big data engines. Okay. We have big data engines, which we own, which we maintain. So we will use these engines to perform the transformation step. But here, if you are just performing transformation while extracting data, you are actually keeping the source engines engaged. Make sense? You are actually putting a lot of load on source. Oh, so you use big data engines. So this is a complete process. Once this is done, then you can say, okay, our data is there. This is called ELT, extract, load and transform. This is not ETL. Make sense? Very good. Now the thing is, everything is fine, everything is sorted. Very, very good. Now, obviously, whenever we want to build any project, build any solution, we need a kind of design. We need a kind of architecture. So ELT is a process, we know that, but what is the architecture for big data? And you know what? You already know the name of it because that particular architecture is so famous. Everyone is talking about that particular process. Now you can also talk about that because now you will know what is that. It is called Medallion Architecture. Okay. Medallion Architecture. If you just look at the word, again, I will repeat my same, you can say, statement that every time you need to focus on the keyword, you will get the answer. Medallion Architecture. That means this architecture has something with medals. Has something with medals. Yes, we have here 3 medals. Number 1 is bronze. Okay. Then we have silver. Then we have gold. Okay. Bronze, silver and gold. Make sense? Bronze, silver and gold. Okay. Why these medals? Like it looks funny. It's funny, but it is very helpful. Remember ELT process? Yes, we remember. Very good. Now you need to revise that. So first of all, let's say I have a source. Okay. And let me just move these names a little bit towards right side. So let's say bronze and then silver and then gold. Okay. Bronze and silver and gold. So let's say we have a source. Okay. The source is like this. This can be any source, let's say any API or anything. Okay. Let's say this is a source. Claude. So let's say this is a source. Okay, perfect. This is a source, any source. Now we will be simply following the ELT process. Okay, but with this architecture. So this is a layer, bronze layer. This is a layer, silver layer. This is a layer, gold layer. Basically, these can be different folders. This can be different systems. These are basically the isolated layers. Okay, let's say one folder, second folder, third folder. One container, second container, third container. Because in the data lakes, we call it as containers. Okay, so what we do, we load this data, this source data directly and dump it in the bronze layer. Okay, dump it. Why do we call it as dumping? Because we do not make any transformation. And I know before transformations or without transformations, data is almost garbage. Not every time, but in some scenarios. It can have duplicates, it can have nulls, it can have so many, you can say missing values and all those things. So we simply dump the data in the bronze layer. Bronze layer is, let's say, you can say as is, as it is layer, or you can say replica of the source. Okay, we simply lift the data from the source and dump it in the bronze layer. Make sense? Then we go to silver layer and we clean it. Okay, this is also called as cleaning or basically transformation. Okay, so here we apply transformations in the silver layer. So extract is here, load is here, and then transform. Right here we will apply transform. Okay, so this is silver layer. Now here the data will be cleaned. You can say cleaned. Perfect. Now this data is cleaned. Now this data can be go to the modeling phase. And what modeling do we follow? We follow something called as dimensional data modeling, which is in the form of facts and dimensions. It can be one big table as well. Like there are so many modeling techniques. It totally depends like what are the requirements for the project. So in short, I will simply write modeling because it can be anything. Okay. And this is called as presentation layer. Why presentation layer? Because this is the layer which will be presented to the stakeholders. What are your who are your stakeholders? Data analytics team and data science team, business intelligence team, business managers, all those people who will use or consume this data, and they will consume this data via gold layer, not through silver, not through bronze, through gold layer. This is a kind of protocol that we follow in the big data engineering. This is the protocol that we follow in the Lakehouse. This is the protocol that we follow nowadays. Simple, sorted. Simple, sorted. Bronze, silver, gold. Now they have some new names as well, or you can say some related names as well in the industry. It is, let's say, called as raw. It is called as enriched. This is called as curated. Okay. Raw, enriched, curated. Makes sense? Bronze, silver, gold. I'm a big fan of bronze, silver, gold. Yeah, but people also call it as raw, enriched, and curated. Makes sense? So this is the concept of Medallion architecture, where you travel your data. Okay, you make your data travel through multiple layers, and total 3 layers: bronze, silver, and gold. Sorted? Makes sense? Very good. Now this is also sorted. Now let's talk about the file formats. Ansh, Lamba. Everything is sorted. Now we need to understand one thing, because a lot of people talk about big data file format, big data file format, big data file format. What is that? What is that? Basically, we make our data travel through multiple layers. Okay. Bronze, silver, gold. You already know. Yes. Obviously, we need to save this data. And in the modern world, in the world of Lakehouse, we save our data in the form of folders, in the form of files, right? You cannot use any file. Why? Because in the world of big data, you need to use special type of files. Basically, there are 2 types of files. One is called row level, or basically raw format. Okay. And the second one is columnar format. Now what's the difference? Difference is very, very simple. Columnar format and raw format. So when you talk about those files, let's say CSV, let's say any text file, all those normal files that you use in a day-to-day activity. Okay. All the file formats are raw based file formats, so basically raw format file formats, which store your data row by row. Which stores your data row by row. For example, let's say there is a table. Okay. And there are basically 3 columns within that, basically 4. So let's say the column names are ID, name, okay, ID, name, email. I know I is missing, you can add it. Okay. Then phone. Let's say these are the columns, and the values are pretty much straightforward. Let's say 1, name is AA, email is ABC, phone is 123. Okay. Then 2, name is BB, email is XYZ, and number is 345. Then 3, then CC, and then let's say blah, 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 and then phone is 999. So let's say this is the table. Now do you know what? In the case of raw format, let's say you want to save this data in a CSV or any raw based file format. Do you know what will happen? Let's say this is the file. Okay, this is the file. Now first row will be saved at once. Let's say this. So first of all, this data will be saved here. Let's say 1, AA, ABC, and then 1, 2, 3. This is one data. Then second data will be saved as like this. Let's say 2 BB XYZ and 3, 4, 5. Okay, and so on. So data will be saved row by row, row by row. You will say what's wrong with this? Nothing is wrong. This file format is very good when you want to make so many updates or changes. Okay, when you want to make so many updates and so many changes. Makes sense. But in the big data domain, we are not actually worrying about updates and changes. We are worrying about reading the data quickly. We want performance. Because big data is big data. We want performance. So here comes the concept of columnar file format. Do you know what will happen in the columnar file format? By the way, the very popular file format is Parquet and I think Avro. I will just show you, don't worry. So if we just save our data in the form of Parquet file format, let's say, so do you know what will happen? So first of all, the whole column will be saved. So whole column, let's say ID column will be saved together. So let's say 1, 2, 3, 4, 5, like all the IDs. Then all the names will be saved. Let's say AA, BB, CC, and so on. Then all the emails and so on. So it will save the data column by column. What is the advantage? Let's say I am querying this data. Let's say I want to fetch only the name column. I can say select asterisk or basically select name from table. So I will literally get this whole column, this whole data in one go very easily because this whole column is saved together. If I query the data and if the data is saved row by row, it will definitely go to each and every row, which is not very performant. This is very nice. Okay, so this is the concept of row based file format and column based file format. Okay, and let me just show you like how you can just visualize it because I think there's a very good blog by Dreamio. I can just show you, wait, column based file formats. I saw one very good diagram by Dreamio. Let me just add Dreamio. Yeah, understanding. Do we have what is let's go to images. Yeah, here. So see what it is doing. So let's say this is our table, logical table, and you can actually go to this link. Okay, so all the credits are for this particular page. You can go dreamio.com, resources, Apache Packet, and we are simply using this particular web page for the educational purpose so that you can understand the concept. Make sense? Yes, very good. So now let's say you are saving this data. Okay, and you have this table. So in the row based file format, this is stored row by row. See, this is the first row. Then this is the second row. Then this is the third row. But in case of column based file format, all the columns are stored together. And do you know what? This also supports something called as encoding. So your data is actually compressed and encoded so that you cannot see the data directly. So that is like another benefit of column based file format. Make sense? So this is basically the Parquet file format that we use nowadays and it is very, very popular. Make sense? And row based file format is CSV basically. Make sense? And you can actually read it if you want, and you can obviously make notes. And it is, I really like this diagram. Okay, so that's why I thought of just navigating you to this particular page because I just want to share the reliable resources with you, right? So that you can just go and just check all those things. Make sense? Okay, very, very good. So this was all about the big data file format. So now we were talking about, hey, let me just check mic check. Okay. Because sometimes it doesn't record the voice. Okay, so it's fine. So now we were just discussing about Medallion Architecture, ELT. Obviously all those things are done. But if you would have observed, the major, or you can say the heavy duty work is actually the processing of big data, because so far we have solved all the problems regarding data storing, data traveling, processes, everything is fine. But I think the major heavy duty work is with the processing. Now just tell me one thing. If your computer, your laptop, your Mac, whatever, has, let's say, 8 GB of RAM, okay, 8 GB of RAM, and you are doing some very heavy duty tasks, okay, and you are realizing, or let's say not, let's say 8 GB, let's say 4 GB of RAM. So you are doing very heavy lifting, okay, maybe you are just playing so much big games, okay, which consume a lot of RAM, or all of those things, right? So what you will do, you will say, Ansh, it's very simple. I will if I want to play that game, if I just want to continue with it, I will simply increase the RAM of my system. Simple. Make sense? Make sense. Okay. But let's say now your computer has 8 GB of RAM, but now you are doing other heavy things. Now you need more RAM. So you will say, I will go to the shop and I will simply get it increased to, let's say, 16 GB of RAM, let's say 32 GB of RAM, let's say 64 GB of RAM. Like this, you can keep on increasing the number of, you can say, RAM chips, or basically the size of RAM, right? But this approach is called monolithic. This approach is called monolithic, where you have one system, but you are, you can say, scaling it vertically. It is called vertical scaling, where you are simply keep on increasing the power, computation, memory of just one single machine. Let's say this is your machine, okay? This is your laptop. So you are keep on increasing its RAM size, like storage size, and all those CPU, everything, right? But after a certain point of time, you cannot increase its computation, RAM, or whatever after a certain point of time. True. Okay, makes sense. This is called monolithic approach. We do not follow this approach. Let's say I want to process big data. Earlier, I was not saving so much of data, so I was just processing everything, let's say, using single machine. Now with the big data, I will not follow monolithic approach. I will not say, hey, increase the size of RAM, increase this, increase that. No. I will simply say, I will follow distributed approach. What is distributed approach? Distributed approach means I will use this system, okay, and I will add one more system. Instead of increasing the computation of one system, I will add one more laptop, one more system, one more computer. And if I have more work, I will add one more. Wow. This sounds promising. Why? First of all, you can add literally n number of computers. There is no limit. Okay. And there was a limit here, right? Because you can increase the size of RAM, let's say till let's say X number of, or basically X size of RAM. After that, you cannot create, or let's say add another chip. There's no space for the another chip. And you can not buy a chip larger than a specific size. But in distributed, I'm saying, hey, just go to the shop and just buy all the computers. Just connect it. So this is called distributed approach, where you are not actually blocked by any kind of limits. No, there is no limit in distributed. Make sense? Is this the only difference? No, there's one more difference. So let's say you are a pro developer, you are a tech geek, okay, and you made your computer a supercomputer. You have, let's say, 1 terabyte of RAM. Wow. Let's say you are very rich and you just bought the max, like the most expensive RAM chip that we have. You have 1 TB of RAM and let's say 1000 petabytes of storage, everything. This is your super machine. Wow. Very well done. Now you will say, I can process any data. I do not need to just have multiple computers. My computer is so powerful. Very good. Clapping. Very good. Now let's process the data. Let's say I have this data. This is the data. Okay. Now this data will go here. Okay. Because it can process it. It is a super machine. This data will go here. And this is actually behaving as a group, because this is a team, right? This is a team. They have multiple computers. Okay. So this data can be processed here easily. We know that. This data can be processed here as well. I agree with your point, because you have made your machine a super machine. Due to any reason, this machine is not working. This machine. It can be a power outage. It can be any kind of fault, because it is a machine, right? It is a machine. Due to any reason, this machine is actually not running and there's an outage. Okay. There is a new set of data, because previous set of data was processed with this machine, because this is a super machine. Now, new set of data is coming. Okay. New set of data is coming. It went here and it processed data because it has multiple machines. Now it is going here and this machine is saying, bro, you need to wait because there is an outage. But we cannot wait, because you know the velocity of data. We cannot wait. So there is a big drawback when you follow the monolithic approach, where you're just trying to increase the capability or capacities of just one machine. You need to follow a broader picture where you have multiple machines. You will say, anshlambacollab, this is unfair. Your machines can also be like, you can say, let's say in the distributed approach, this machine is having outage. So this approach has multiple machines, and this approach can add more machines. Oh, okay. So now I am also on this side. I know that. So that is why we follow something called as distributed processing. Instead of monolithic processing, we use distributed processing, or you can say distributed compute we follow with the big data. Make sense? Make sense? Monolithic and distributed. So one thing is clear, if we want to process big data, we want to include multiple machines. If we want scalability, if we want efficiency, if we want durability, everything, we want multiple machines. Sorted? Okay. So in the world of big data, we use frameworks which are built to support distributed computing or distributed processing. Make sense? Make sense? Very good. So now what is that X factor? What is that framework? So very popular framework that we were using before, I would say 2009 or 2010. It was Hadoop MapReduce. Hadoop MapReduce. Don't worry, I will just explain you what is that. Hadoop MapReduce. You would have heard about this particular Hadoop word, at least not MapReduce, but at least Hadoop, because Hadoop is basically the ecosystem where we have so many services, so many frameworks, but MapReduce is one of the frameworks or basically services within Hadoop. Okay, so Hadoop MapReduce. So Hadoop MapReduce is actually made up of two words, map and reduce. Map and reduce. So basically this is a process. This is a two-step process. Okay. So let's say this is your big data. As you can see, this is so big. Okay. This is your big data. Now this big data cannot be processed in one go. As we just saw in the previous example, we need to distribute this data to multiple machines. So let's say this data will get distributed to multiple machines to process it. Okay, so basically this big data will be splitted into smaller chunks. Now this splitting of our data into smaller tasks is called mapping, or basically this task is called map. Okay, this is map, where this data will go to multiple machines. Okay, and they will simply map it, basically dilute the tasks. Hey, you take this much of data, you take this much of data, you take this much of data, and you can all just process it. Okay, so what it will do, it will simply perform all the transformations. Okay, all the transformations, whatever they just want to apply, all the intermediate results will be stored in the disk. Okay, all these results will be stored in the disk, let's say here. Okay, so this is mappers. These are mappers. Now the reduce step will come into the picture when map step is completed. So reduce step, what it will do, it will simply take the results from this disk, okay, and it will combine them together and it will present the final output, because obviously final output should be just one entity instead of having multiple data. Okay, so this is called map and this is called reduce. This is map, and when we just combine the results from these steps, this has become reduce step. This has become reduce. This is map, this is reduce. Make sense? Okay, so now this was the hero of the picture till 2008 2009. Okay, then what happened? Then new hero came into the picture. Really? And why? So just to explain what happened, you need to remember one thing, that Hadoop map reduce writes all the intermediate results in the disk every time. As you can see, mapping happened, then they applied transformations, intermediate results appeared, and all were saved in the disk. Then reduce step come into the picture and they just read the data from the disk and then again display the data, right? So this step of going back to the disk to write the data, to write the intermediate results, and going back to the disk to read the data from the disk and then just display it, or let's say creating the output. So this going back to the disk every time was time consuming, was literally taking a lot of time. So then developers thought, is there any way we can eliminate this step, like writing the intermediate results into the disk? Is there any way? Because this whole step is of no use. We do not need to write the data to the disk. Obviously, there are so many advantages. Let's say, I remember there can be some outages in the machine. So let's say this machine is failed. So what it will do, this machine's intermediate results are saved here, right? So it doesn't need to dependent on this particular machine to just provide the output. Reducer can just go to the disk and grab the results. And then they can further divide this task to other mappers, but they are not actually dependent on, you can say, machines, because they can just handle this fault tolerance, because data or intermediate results are being stored in the disk directly. Okay, makes sense. Now we wanted to remove this step. Okay, so now this gave rise, or you can say this actually invented something called as Apache Spark. Okay, and what it did and what is it, just let me know. Basically, Apache Spark does not write the data of, you can say, intermediate results to the disk. It processes everything in the memory, that means RAM. So it never goes to the disk. It doesn't mean like it never goes to the disk. It goes to the disk, yes, when it needs to, but it will go to the disk when it doesn't have enough space in the memory. But if it has enough space in the memory, it will try to perform all the transformations in the memory itself. Make sense? So what is that secret sauce behind Spark? Like how it can just do all of these things? Because we need to handle fault tolerance, we need to just get the data in the right manner. Like what is that secret sauce? So secret sauce is basically the DAG and RDDs. Okay, so first of all, DAG. What is DAG? So let's say I have some data. So this is a like normal table that we have. Okay, let's say I have ID, name, email, and let's say phone. Okay, so this is the table. let's say I want to apply some transformations. So first of all, I want to apply, let's say, filter. Or let's say I want to first of all select the columns. I want to select some columns, okay? And then this data will look like, let's say this, only 2 columns, okay? Let's say I just want to select ID and name. This is my one transformation, okay? Then I want to filter out this data, and this data will look like this, right? Let's say I just want to filter only 1 record or 2 record. Okay, so these are my transformations, ID and name. Okay, so here is a filter. Make sense? So what will happen? So this is basically a DAG. DAG means directed acyclic graph. What does it mean? Directed acyclic graph. If you closely look at the graph, this is a graph, see, this is a graph. So this is, let's say, step number 1, this is step number 2, this is step number 3. Oh, okay. This is step number 1, this is step number 2, this is step number 3. So DAG means directed graph. Like this is, first of all, you need to understand directed graph. That means it is directed. It is saying, hey, this is step number 1. Then this is step number 2. You don't need to directly jump to filter. No, you first need to follow the select and then filter. So we are directing it, like in which direction you need to go. What is the path you need to follow to reach to the end result? So this is directed graph. What does it mean acyclic? That means it is not in a loop. Now see, the arrow is actually ending here at the last step. It is not returning this arrow back to the starting point. This is called acyclic. It is not creating a cycle. It is not creating a loop. It is simply acyclic. Make sense? Make sense? Now very good. Now you will say, Ansh, Lamba, DAG is fine. Okay, we have the picture, like how we need to proceed, but what are RDDs and how it handles the fault tolerance? Because in Apache Hadoop MapReduce, Apache Hadoop MapReduce, we have the intermediate result sitting in the disk. So we can just go and just check the data and fetch the data again. But how RDDs will handle it? Because data is in the memory and memory can be just removed like this. Memory is like temporary data, right? It does not hold anything for a longer period of time. It simply releases the data. So here comes the concept of RDDs. RDDs actually help to take care of all of those things. All of those things. Really? Yes. All of those things. Okay. Makes sense. Can you just try to explain? And first of all, just tell us the full form of RDDs. RDDs full form is Resilient Distributed Dataset. Resilient Distributed Dataset. RDDs. Okay. Make sense? Make sense? Okay, so now let's talk about RDDs in a little bit detail so that you can understand the concept of Apache Spark, like how it handles those things. Because once you understand this, your fundamentals are clear and you are good to go. Okay, so let's try to see. So let's talk about RDDs a little bit in detail. So first of all, let's start with the definition. It says resilient distributed dataset. Basically, this is the concept of just 3 words, and if you understand these 3 words, you understood the whole concept. Just in brief, RDDs is just like a data type or data structure. Have you seen list? Yes, it is a data structure, right? Okay. Have you seen dictionary? It is a data structure, right? Have you seen tuples? It is a data structure, right? Similarly, RDDs is also just a data structure, but in Apache Spark. So what is special in this data structure and how does it look like? It is very, very, very similar to a list. It is very similar to a list. So it will look like this. Let's say this is a list and this is the data 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this RDD will look like very similar to this list. Makes sense? But there's a speciality of this list. If we create a list in Python or in any programming language, we cannot share that list in different machines, right? It cannot be shared. RDD is a list which can be shared. So let's say I have two machines, machine number 1 and machine number 2. I can send 1, 2, 3, 4, 5 to this machine, 6, 7, 8, 9 to this machine, and it will still work. So we can actually split or share this particular list, which is a data type, which is called RDD. Okay, that is why it is called distributed. It can be distributed among machines, among nodes, whatever you want to say. What does it mean by resilient? Resilient means, let's say this is basically the RDD, the complete RDD. So if I say this is my complete RDD, right? This is my RDD 1. For now, let's say RDD 1 is a variable name and this is its data. Okay, this is its data, which is distributed into 2 subsets, or you can say sub data sets. Okay, now resilient, let's say this RDD1 failed. This RDD1 failed, or let's say this part of the RDD failed, or let's say this part of RDD failed while processing the data. Then it can recompute this RDD. Really, yes, it can recompute this RDD using DAG. Because it has the list of tasks it needs to perform to create one RDD. And then so on. Let's say it needs to create another RDD. And it can create the second RDD using the DAG. So it is fault tolerant. That is why it is called resilient. I know everything is not clear to you. I know that. That is why I have a very good example so that you will understand it. Okay. So let's suppose this is your data. Okay. Just having 2 columns and 4 rows. Simple. Now you can imagine that this is a big data, very big data. Okay. Let's say 4 million records. Now we have 2 machines in my processing unit. Okay. Or you can say basically it is technically called as cluster, and we'll just talk about cluster as well. Don't worry. Cluster is basically the team. Remember we just talked about the distributed approach where we have so many machines. So when we just combine those machines, it is called as cluster, nothing else. Okay. It is just a fancy name. Okay. It is a cluster. Okay. So these 2 machines are cluster. So now what I will do, first of all, I have this data. Remember we just share the data across multiple machines so that we can just process data better. So let's say we have 4 million records. So 2 million records are here, 2 million records are here. And these 2 million records will go to this machine. These 2 million records will go to this machine. So they have shared the tasks. Okay. Simple. And so far it is very, very simple. Okay. Perfect. So now we know that this machine will be processing this set of data. This machine will be processing this set of data because this is a distributed framework, right? Now, what will happen? This is my RDD1. Okay. RDD1. Because this is a shared distributed, you can say, data set. This one and this one as well. So when we combine all the partitions, basically logical partitions of the data, it becomes RDD, right? So this is the RDD1. What is 1? 1 is nothing but you can say state. 1 is, let's say, you can say level. So this is my first state of my RDD, RDD1. Common sense? Very good. Let's say on this RDD1, okay, I want to apply same transformation that we just discussed before. Let's say I want to perform select statement. Okay, I want to select the data, select only one column. Make sense? So what it will do, it will apply the transformation. Yes, and it will create these 2 partitions. This will be called as RDD2. This is the second state, or basically second version of RDD. This is the first version. This is the second version of it. Now let's say after this, we want to apply a filter, and I just want to filter even records. Okay, 2 and 4 and 6 and 8, all the even records. Okay, this will become my RDD3, basically the third version of my RDD. So on, it will create every time a new version of RDD. That means RDDs are immutable. That means we cannot change RDD1. No, this is RDD1. If we want to apply any transformation, anything, we will create a new RDD. We cannot change any RDD. No, we have to create a new RDD. What is the advantage of it? Let me just tell you. Let's say you have performed RDD1, which is simple distributing the data. Then RDD2, you simply selected the ID column. Perfect. Now, while creating the RDD3, it actually failed due to, let's say, any reason. Okay. So now it does not need to worry. Why? Because RDD1 is there. This is the RDD1. RDD2 is there. Oh yeah. And it can quickly create RDD3 because we didn't change it. And in reality, RDD1 is not there. RDD2 is not there. But it has the rules. In what form? DAG. It has the steps how to create RDD1, how to create RDD2, and how to create RDD3. So it will quickly recreate RDD1 and RDD2 and then will retry this particular step again. Make sense? This is the advantage. This is the advantage of creating and not updating the same RDD and creating a new RDD for every transformation. This is very high level, you can say, understanding of Apache Spark. And yes, we have a dedicated course on Apache Spark as well, where you will see all the other things as well. But you need to understand the concept, like how distributed framework works. Make sense? So this is all about your RDD. Make sense? Now you will say, Ansh, Lamba, how this distribution works, how it just allocated, and how those two machines are there in the picture, like how the whole framework works. Yes, we have a dedicated course on Apache Spark that you will be getting at the end, but I will still show, and don't worry, it is it is free, it is not paid, it is still on YouTube. It has a different video, dedicated video on Apache Spark, but still I will just make you aware about the Apache Spark architecture, which will answer and just clear your doubts regarding Apache Spark. Okay, so let's try to see the Apache Spark architecture. Now let's try to understand the Spark architecture. And I will not use any kind of picture like diagrams which are already on the internet, because I want you to understand it, and I will draw everything live so that you can understand everything which is going on for Spark architecture. Okay, let's go. So first of all, let's say you are the developer, okay, and you have let's say 9 machines, okay, 9 computers. Let's say 3 computers for now. Let's say you have 3 computers, okay, 3 computers, or basically 3 machines. In the Spark world, we just call it as node, okay, node. Just a fancy name, but it is a computer. Okay, simple. So now what I will do, I will also have something called, this is basically a cluster. Okay, this 3 machines cluster. Okay, this is my cluster. Basically, I have the quota of 3 machines. Perfect. Along with it, I will also have one cluster manager. Okay, cluster manager. Perfect, cluster manager. Now, let's say I have this data. And I want to get it processed. Okay, and this is a big data. Let's say 1 terabyte of data. Okay, now what I will do, I will simply say, hey cluster manager, hey manager, hey cluster manager, I want to process this data. So I will simply hit the submit request. Okay, submit request. Let's say I'm just submitting my data or submitting my request to cluster manager. Hey, this is my request. Make sense? And I will also say, I know that you have 3 machines. Okay, just do one thing. Give me 1 driver machine and 2 worker machines. Now stop here. What is driver machine and worker machine? Basically, in the Spark architecture, there is always Okay, there is always two concepts, driver node and worker node. Basically worker nodes, because there is only one driver node every time, not more than one, and worker nodes can be, let's say, infinite. Okay, infinite, literally infinite. Do not create infinite, but yeah, you can create as many worker nodes as you want. So what is the difference between two? Very simple. I will just let you know, but don't worry. So I will simply say, hey, just give me one driver node and two worker nodes, because I know you have 3 machines. So cluster manager will say, okay, sir, as you said, let me just do that for you. So it will simply do some magic, and it will simply, cluster manager will, let's say cluster manager is here. Okay. So cluster manager is here. Cluster manager will pick this machine, let's say this machine, and it will create a driver node. Okay, it will create a driver node, driver machine. Now what is driver machine or driver node? Driver node is the brain. It is the brain. Okay, it is the brain. It knows everything, what to do, how to do, all the steps. Remember, this person, basically you had some data. So what it will do, cluster manager will first of all will create this particular driver node, and it will relax after that. Then driver node will read the data. It will read your request. Okay, you want this. Okay, you want to process this. Okay, you want to apply these transformations. Okay, so driver node will create a detailed, you can say, steps. It will create a DAG, directed acyclic graph. It will create the information for RDDs. Remember, like how many partitions we should have in that particular RDD, because we just partition our data, right? So all that information will be created by driver node. And once it is there, then it will call cluster manager, hey bro, okay, like this. Hey bro, I have prepared everything. Okay, I have prepared literally everything. Now I need workers. Okay, because driver node will not work anything, will not perform any kind of work. No, driver node is just the brain. It is just the team lead. Okay, it is the team lead. It will simply guide the team how to work, what to work, all those things. So this is the team lead. Okay, so it will say, bro, I need 2 members from my team and I want this work to be done. So now cluster manager will follow all the guidelines by driver node, and it will create 2 worker nodes as requested by the user. Okay, so it will create 2 worker nodes. Okay, like this. So it will be here 2 worker nodes. So let's say these 2 worker nodes are here. Let's say worker 1 and worker 2. Okay, worker 1 and worker 2. Perfect. So now what will happen? So cluster manager has created these 2 machines, and these are ready to do the work. Now cluster manager, first of all, see, just revise the concept. First of all, data went to cluster manager. Cluster manager created driver node. Okay, makes sense. So let me just mark the rankings as well. So first of all, this cluster manager was created, like cluster manager was always there. Okay, this driver node was created, number 1. Okay, then driver node prepared all these things. Okay, so number 2, then it requested back to cluster manager, hey, I want 2 workers. Okay, so it created these workers, and this was step number 4. Okay, step number 4. Now worker machines are also there. Now what will happen? Cluster manager will say, my work is done, because I have provided driver node, which is a team lead. I have provided the team members as well, who are the worker nodes. Now my work is done. Okay, and that's what I think managers actually do in the real life as well. So they just set up the team. That's it. The actual work will be done with the effective collaboration between team lead and team members, right? So it will come out of the picture, cluster manager. Now this team lead will directly talk to these 2 workers, and it will say, hey, you need to process this data. Okay, you need to create these partitions. Okay, and you need to read only this partition of data, and you need to create multiple RDDs based on this information, and you need to create basically these RDDs based on the DAG. So it will pass on all the information directly this time. This is step number 5. Directly to the worker nodes. And worker nodes are actually the ones who perform the processing, who perform the data processing. And once the data processing is done, then they will simply send the results back to the driver node. Okay? Same thing. It is the same thing that happened in the real world. Team lead will say, you need to complete this task, this task, this task by today. All the workers, okay, all the developers will start developing. Once everything is done, they will show the work back to the team lead. Okay, and team lead will just show the result to the manager, or basically to the user, to the end user. That's it. This is the concept of, you can say, Spark architecture. Make sense? Make sense? That is why I created this diagram live, so that you can understand all the arrows, like how everything is going, how everything is being done. Now a lot of people argue, hey, first it creates the driver node, and then it creates the cluster manager, and then it creates the worker nodes. Bro, no. It always, the request will always go to the cluster manager for the first time. Cluster manager will create the driver node. Driver node will not be created automatically. Cluster manager will create the driver node. Once driver node is there, then let's say you are sending another request, then yes, it can go directly to the driver node because it is already there. So you need to understand this. Make sense? So this is the concept of Spark architecture, and I hope now it is clear. So this is basically called data processing, big data processing. Yes, we have a dedicated course on Apache Spark as well that you can just enjoy, that you can just learn a lot of things, including coding, including concepts, because Apache Spark is a very, very, very big subject in itself. Concepts, stages, RDDs, processing, PySpark coding, everything. So yes, we have a dedicated video on that as well. It's called Apache Spark full course. You will get the resource, don't worry, video link at the end of this video. So this was all about Apache Spark architecture. Make sense? Make sense? Now you are actually living in the big data world, because now you can understand those concepts that you were totally unaware of. Happy? Now let's see what do we have next. Let me just show you what do we have next, because now we want to talk about some popular technologies which are using Apache Spark and which have actually made Apache Spark so easy to work with. Because see, you would have assumed basically like this is a kind of very painful task to manage this cluster, to manage all the machines, right? And the answer is yes. But with the big data technology softwares that we have right now in the market, this task is very easy. You do not need to worry about managing the machines. You just need to worry about writing the code. That's it. And let's talk about something called as Databricks. I know you would have heard about this technology. Now it's the best time to talk about it. Okay, let's see. So now let's talk about Databricks, because in big data world, I would say you will definitely hear about this word, basically this technology, this software, whatever you can say, Databricks. And actually Databricks is something that is actually revolutionizing the AI data engineering world, or basically AI data world, because it has all the things that you need. Everything is there. And before even talking about Databricks, we want to know like why do we need Databricks and what is the problem that Databricks is solving. So remember, we were just running Apache Spark clusters, right? Yes. Where we were just simply creating driver node, worker nodes, cluster manager. It is a pain point when you need to manage all of these things manually. Yes, it is a pain point. So in order to get rid of these things, Databricks provides the solution. It is basically the managed service for Apache Spark, or you can say like this is a managed layer that is applied on top of Apache Spark. Okay, so that means you do not need to worry about clusters, you do not need to worry about cluster manager, you do not need to worry about driver node, submitting the request and waiting and shutting down the services, all those things. Everything will be taken care by Databricks, everything. Okay, And it's not just about like creating a managed layer on top of Apache Spark. It is much more than that. It has amazing data lineage capabilities, data governance capabilities, which is called Unity Catalog. Databricks has developed something called as Delta Lake that we will be just talking about very, very soon. So everything is created by Databricks, even Apache Spark. Really, yes. So the original creators of Databricks actually created Apache Spark and they just made it open source in 2009. And then they created the, you can say, managed layer on top of it, and they created a product out of it, and it's called Databricks. So yes, we do have a dedicated course on Databricks as well, but you need to first of all need to understand like what is Databricks, and now you should have some basic understanding like what is Databricks. Makes sense? And the good thing is you can literally start exploring Databricks like this. Why? Because Databricks is free. It's not free, it is free for just you. Why? Who are you? Basically, Databricks has started providing free accounts for the educational purpose, so that you can just learn Databricks, you can just try Databricks, and you can just make use and make the best use out of that free account. How we can just create that account, I will just let you know, don't need to worry. Okay, and I will also give you a quick demo like how Databricks look like and what is the UI and how do we work with Databricks. Okay, and obviously we have a dedicated course on Databricks which is also available for free on YouTube, that you can just also watch to master Databricks. And before that, let's have a quick overview of it. So okay, so let me just go to this particular, you can say, Databricks. So this is my personal account of Databricks, which is a free account, as you can see, free edition. See, you can also create a free edition. It's very, very simple. Simply go to your favorite browser and simply search Databricks free edition and click on the first link, try Databricks for free. So it is saying get started with Express setup. Okay, and if you do not want to set up or basically start with Express setup or set up with your cloud, it is like you can just simply ignore, because if I click on go back, you will see something called as sign up. So this is the sign up for Express setup, which is also free, but you will only get the free Databricks workspace for only 14 days. But if you just want to use it for longer, you need to click here, get free edition instead, which is free, like free after 14 days as well. Okay, so simply click here and then create your account. And once you have that account, then you can simply click on this button, login, and it will take you to this page. So this will be your home page after that, and everything is there in that particular course, so you don't need to worry about that. So basically this is the Databricks workspace. So here we do not need to worry about any clusters. We do not need to worry about any VM. We do not need to worry about driver node, cluster manager, nothing, literally nothing. What do you do here? Simply write your code and that's it. If I show you my workspace, okay, so I have so many folders here. I have created so many things. Okay, so let's say I want to open or basically create a new workspace. Okay, I will simply go to create and I will create a new folder and I will simply say Databricks demo. Okay, click on create. Let's say now I want to write my PySpark code, and I will literally show you how quick it is with Databricks to write your PySpark code, because in the real world, basically when there was no Databricks, people were actually installing first of all PySpark, Spark, then they were just creating environment variables, then they used to create or basically import PySpark libraries, then they just used to integrate it with your code editor, then they used to just work with it, and then they just need to create cluster on their own. So it is a pain point. But with Databricks, you do not need to actually worry about anything. So I will simply create a notebook. Basically, what is notebook? You should be aware about notebook, because notebook are like very common nowadays. Notebook is basically the interface where you can just run your code cell by cell. Okay, very similar to Databricks notebook, or sorry, Jupyter notebooks. Okay, so let's say I want to run any code. What code? Let's say if I go to catalog, basically this is a data catalog where you see all the databases, all the tables. So let's say I want to open this catalog, and these are all these schemas, as you can see, bronze, silver, gold, all these things. And within this gold schema, I have no data. If I go to silver, I have 11 tables. So let's say I want to query this table, customers enriched. Okay, so what I will do, I'll simply write the code for it. I will simply say spark.sql. Okay, and then I will say select asterisk from, and I will simply drag it here. So it will simply pull this particular location. Okay, and if I just run it. So obviously in order to run this code, I need a cluster. So this is the button from where I can just connect the cluster. I will simply click on connect and serverless. So this cluster is managed by Databricks. I do not need to do anything. So see, this is on in just few seconds, So I can simply run this code and I will simply say shift plus enter. So shift plus enter is a shortcut key to run any cell. You can also run the cell from here as well, from this blue button, but I will not do anything. I will simply say shift plus enter and then this is running my code. Okay, I can even interrupt it, but I do not want to do that because it is running this code and it will return me the data. First command takes time because it just warms up all the things, and once first command is done, then you can simply see. So this command is executed, that you can see. Let's say I want to display this command, so I will simply create a data frame for this and I will simply say display df. This is just a demo code for PySpark. You do not need to worry about this thing. Oops, let me just run this first of all and then display df. Perfect. So this is a PySpark code that we write, and yes, we do have a dedicated course on PySpark as well that I will just show you, don't worry at all. So this is display df, which will simply display the data. Okay, so this is my data that I have, right? This is the data that I have. So all the things are possible within a few seconds because I am using Databricks. Because I do not need to worry about cluster. I can simply start writing my code. This is the power of Databricks. Make sense? So the intent of this particular section of this video is not like making you a pro Databricks developer. No, this is just like making you familiar with the word called Databricks. There is a technology that exists in the industry which is booming right now. So now you are aware of this technology and why do we use this technology? Make sense? Now you have a dedicated resource as well to master this technology that I will just tell you at the end of this video. Make sense? So this is all about Databricks. Make sense? Very good. Now I want to show you, or basically make you aware about open table format which is created by Databricks. It's called Delta Lake. Remember, we were just talking about Delta Lake, Apache Iceberg, Apache Hoodie. So it's time to actually see the architecture of Delta Lake. How does it take care of all the data warehousing capabilities under the hood? And it's really, really important for big data engineering. Make sense? So now let me just show you that part. Now let's try to understand Delta Lake, or you can say open table format. But as we know, like Delta Lake is the most mature open table format that we have, and everyone talks about Delta Lake. And if you are targeting Azure Data Engineering, Azure Big Data Engineering roles, then Delta Lake is the bread and butter for you that you have to know. So basically, we have again the dedicated course on Delta Lake as well. But I want you to understand the concept first of all. Basically, we know that our data sits in the data lake. Remember the architecture, Lakehouse architecture? Yes. So first of all, let's create the data lake. Let's say this is the data lake. Okay. Let's say this is the data lake. Makes sense. And within this data lake, the data will be sitting in the form of files, because this is a data lake, right? So data will be sitting in the form of files. So let's say this is my file number 1. This is my file number 2. This is my file number 3. And what will be the type of file? The type of file will be columnar based file format. Okay. Columnar based file format. Okay. Makes sense. Now, what type of columnar based file format we'll be just picking, because there are so many. So we pick something called as Parquet files. Okay. We pick something called as Parquet. .parquet. Okay. So let's say this is Parquet file 1. Okay. This is Parquet file 2 and this is Parquet file 3. Makes sense. Make sense? Okay. These are the Parquet files. Now, do you know what? These are just the files. This is still a data lake because data is sitting in the form of files in the data lake. Now, in order to convert it into a lake house, we will add something called as transaction log. Okay. It is called delta log because it is a delta lake. Okay. Delta log. Okay. So now what this will do? This is basically a special folder. Okay. Which holds the transactions. Okay. Which holds the transactions. Now what kind of transactions? For example, this data is added. This file is added. Yes. This information will be stored here. Okay. This file is added. This information will be stored here. this file is added, this information will be stored here. Let's say we modified some data. So let's say this file is modified. Let's say this one. So this information will also be stored here. Oh, so all the transactions are saved in this particular folder in the form of JSON files. So for every transaction, there will be a new JSON for every transaction. Okay. So how it performs the data reading. So let's say there is a user and the person wants to read the data from this particular Lakehouse. So what will happen? The engine will first of all go to the Delta log and it will read all the transactions, all the JSONs. Okay. Then according to the JSONs, it will try to look for the associated Parquet files. Because let's say after adding these three files, I removed this file. Maybe let's say I deleted this data. So that means we do not need to read this data. So that information will also be there in the transactions log. So it will know that it doesn't need to read this particular file because it is written in the transactions. So that's how, let's say you are applying a read, basically any kind of query on this particular data lake, it will know like it does not need to read this file and it can ignore this. So all of these transactions will be saved here. Now a quick question can be, Ansh Lamba, there can be millions of transactions, right? Let's say I added some data today, tomorrow, day after tomorrow, and every day I add data, let's say 100 times at least. So there will be like millions of JSONs. Like, will it not create any kind of burden on this particular reading the transactions? You are actually right. Yes, it can. So that is why there's a concept in Delta Lake. So let's say you have 10 JSONs. Let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now the 10th JSON. Now this 10th JSON, what it will do? This 10th JSON will sum up all the transactions into this file. So it will not read all these 10 files. It will simply read this file. Okay. And let's say there's another transaction now. So this transaction is, let's say 11th transactions. Now 12th. So now if I am reading this data from this particular storage, I will go to a transaction log. So I will simply remove all these transactions and I will simply start reading from the bottom. And I will simply read the last 10 files. Why? Because I know that this is the version that has all the previous transactions. So I'll simply read last three, 12th, 11th and 10th. And I will stop here. Why? Because I have all the information in this file. So this way, it will not read your millions of transactions because it has a summarized version of your files as well. Like what information, what metadata and everything. Make sense? Make sense? Make sense? Make sense? So this is basically the concept of Delta Lake, where you do not need to worry about, hey, I need to apply data warehousing conditions and all those things, because this Delta log actually takes care of all the things. If I talk about ACID properties, that means atomicity, consistency, isolation, durability, everything, it will be taking care of everything. How? Atomicity. Atomicity means whether the transaction happened or not happened at all. So what will happen? Let's say this is the Parquet file, this is the Parquet file, and this Parquet file, third one, was actually corrupted due to any reason. Let's say it didn't reach to a destination and it was corrupted. So the transaction, the information about this file will not be stored in the Delta log. And if it is not stored in the Delta log, it will not read that file. That guarantees atomicity. Okay. That guarantees atomicity. Makes sense. Makes sense. Then comes the consistency. Now, if we talk about, let's talk about consistency after this. Let's talk about, first of all, isolation, because this is one of those features that we cannot ignore. Isolation means, let's say this is the data. Okay. The same folder, the same data lakehouse is writing more data. Okay. And at the same time, you are reading the data as well. So it guarantees the isolation, that each transaction is isolated from one another. It will not conflict. It will never conflict. Make sense? Then durability. Now durability, what is durability? Just any guesses? So basically, when we just talk about durability, so durability means, let's say your Delta Lake, this lake house has some data. Okay. Now, due to any kind of outage, Lakehouse is like, maybe let's say, is not available, its endpoints are not available due to any reason. We do not need to worry about anything that happened to the database. We want to see the data like all the time. All the time means all the time. We do not worry about your outages, or we do not worry about all those errors. We just want to see the data. So that is called like durability. When you say, it guarantees that if your transaction, or basically data, has been committed, data is added, its changes are permanent and will survive any system failures. Make sense? If I have added the data, if it has made a commit like, hey, data is there, it will be there. It will be there. Okay. Now let's talk about consistency. Basically, this is the property that ensures that a transaction brings the data frame, because we would just work with data frame, makes sense, from one valid state to another. Makes sense? For example, you are adding some constraints. Let's say you want not null, you want unique, you want all those constraints. So it will make sure, and it will guarantee that any data written to the database must be valid according to all defined rules, constraint, triggers, everything. And like any integrity checks, if any transaction, if any data or anything violates anything, it will simply fail the flow. It will not let it store the data, and it will say, hey, I just skipped that rule and it is fine, you can just ignore that. No, it will simply fail the flow. It will not let it write the data. If I am saying that I just want 3 columns in my target, I want 3 columns. You cannot insert the 4th column. If you have 4th column in your data, that is a kind of failure that it should return, because data should be consistent, right? Make sense? So it allows all of those things. And this is not enough. Delta Lake provides you amazing optimization techniques as well, like Z ordering, optimizing, and then now more recently liquid clustering. Along with that, you also get amazing features like schema evolution, and all those things are there that makes it even more powerful when you just want to work with big data. Make sense? Big data. So I love Delta Lake. I love Delta Lake. I have created a dedicated course on Delta Lake. Okay, you can just go and just master Delta Lake, because it is the backbone of it. Yes, there is another format which is called Apache Iceberg, which is the, you can say, alternative to Delta Lake, but I don't think so it is mature enough. Delta Lake is the most mature and most trusted open table format so far. Plus, Delta Lake gives support to all the other open table formats. It is called Uniform. Uniform allows you to just work with all the table formats together. Okay. So this was a quick brief introduction about Delta Lake that you should be aware of. Okay. I'm just building your fundamentals. That's it. Not going in deep, not going in hands-on, just the fundamentals, because fundamentals will be your backbone throughout your journey. Make sense? So this is all about the Delta Lake. Very good. Now let's try to understand some other frameworks which are very, very popular, and obviously which are like bread and butter for a big data engineering. Let's try to understand that. So now let's talk about Apache Airflow. This is one of the most favorite topics of every big data engineer, because this is the backbone of all the orchestration. In short, what is Apache Airflow? It's my personal perspective. Apache Airflow is already very well, you can say, hyped software, and it is used almost everywhere. But it's my personal take. Yes, Apache Airflow is very, very famous. I'm not saying like it is not famous, but with the course of time, it will become even more famous. Why? Because it is a complete AI data engineering framework. If you have heard about some frameworks called as LangChain, LangGraph, do you know what? Apache Airflow just needs a little bit more support more classes, more libraries, not libraries, I would say classes. If they build those classes within this framework, they can easily dominate this space, because obviously Apache Airflow is dominating the data engineering space. It can even combine the AI space as well. I'm not saying like it has not entered in this domain. They have already entered. They have LLM support, everything. But if they can just integrate all the LLMs like LangChain and LangGraph has done, it can literally perform very well, and it will become even more famous. And I know they will be doing it. They're like very smart people behind Airflow. They will be doing it. Plus Apache Airflow is being used in all those modern top notch companies. OpenAI, just name any company. Wix, just name any company, you will see Apache Airflow. So Apache Airflow is the backbone of, you can say, modern big data engineering, because it is pro code. You need to write all the code, whatever you want to do, and you can literally perform anything. In short, Apache Airflow is the data orchestration solution. Okay, data orchestration solution under the hood, where you can just orchestrate your data. Orchestration means, let's say you want to create a DAG, okay, and it's not just a PySpark DAG. No, it's not a Spark DAG. It's completely different. Let's say you want to create some tasks. Now, what are the tasks? Let's say task number one is and I will just call it as, let's say, T1. T1 will literally fetch the data. Okay, it will fetch the data. Let's say from weather API. Okay, then my task number two will T2 T2 will fetch the data from data lake. Okay, from data lake. Now my task number three will, let's say, combine both the data, transform the data or whatever. Okay, let's say this will combine the data. And then I want to just do, let's say, one more thing like this. Let's say there's another task here, right? Like this. And there's one more task here I want to perform in parallel, like this. So all of this orchestration I want to automate. I don't want to manually run T1, T2, T3, and then T4, and then T5. No, I want to automate this. So in order to automate this whole orchestration, this is also called a pipeline. This is also called a job. This is also called DAG, whatever you want to call. So I want to automate this whole thing. Then I can simply say data orchestration, and I will use simply called as Apache Airflow. Yes, this is not a low no code solution. This is a pro code solution. You need to write code for each and everything. The good thing is it goes very well, and it is obviously a kind of Python package that we can just use. So if you know Python, you can literally start learning about Apache Airflow like this. And don't worry, I will just even show you the quick tutorial as well. I have just prepared something for you, very special. I literally spent so much of time to set up Airflow, because setting up Airflow is not a very easy task and not a very difficult task as well. But you need to follow the steps. If you follow all the steps, you can just set up Airflow easily. Otherwise, okay. So this is a quick overview about Airflow. I will also take you to the documentation of Airflow. Because Airflow, not with Docker, Airflow is recently, I would say, totally changed, because with the latest upgrade of 3.0 of Airflow, it has totally changed the dynamics of Airflow. They have introduced cool decorators for tasks, DAG, assets, all those things. UI is totally changed. Like Airflow is, I would say, totally changed. Totally changed. So if you were using Airflow, let's say 2 to 3 years back, I'm not saying like that knowledge is totally garbage. No. But that knowledge needs to be updated, bro, because there's a new way to write the DAGs. There's new way to use the decorators. They have literally, you can say, introduced so many cool features, which actually saves you a lot of time while writing the code. So let me just take you to the documentation of Apache Airflow. And what is Apache Airflow? It is written is an open source platform. That means it is completely free for developing, scheduling, and monitoring batch oriented workflows. Airflow's extensible Python framework enables you to build workflows connecting with virtually any technology. A web-based UI helps you to visualize, manage. Yes, they also provide you web user interface, which you can also explore in your local host. I will just let me show you the complete end-to-end example because I know you are really excited. And let me show you the new UI. If I simply scroll down, see, amazing UI, amazing code, and I have literally prepared a cool example for you. So first of all, let me just take you to my Docker. So basically this is Docker, Ansh Apache Airflow. This is the container that I have created. Okay, this is the container that I have created, and in this container all these images are running, and these are the three major images: Redis, Postgres, and Apache Airflow. How did I download this? How did I just do this? We do not need to worry about those things. So there's a Docker compose file which is available on their Apache Airflow website, official documentation. You can simply download that and you can simply create your Docker container easily. Okay, so I have this folder, not like this folder, like this is, you can say, my VS code. Okay, and here I have this Docker compose file that I have downloaded from Apache Airflow. If you do not know about Docker, do not need to worry. Docker is basically, you can say, containerization solution, and you do not need to worry about that thing for now. It is like normally a CI/CD thing. But Docker compose file in a nutshell is, let's say you just want to run something, but not on your machine, in a lightweight virtual machine which is installed in your machine, which is called Docker Compose. So what we will be doing, we will simply create a lightweight virtual machine, okay, using this Docker Compose file, which has everything that you can see written. I didn't write this code, I simply downloaded this file. So now what I will do, I will simply, first of all, let me just shut down my services. So Docker Compose down. Perfect. So currently I'm just shutting down all my services because my container was running. So I just want to make sure everything is stopped. So let's run everything from scratch. So whenever we just create, or let's say download the Docker file, you need to create 4 folders. One is called config, second is called tags, third is called logs, the fourth is called plugins. You can also say, let's say Airflow init, something like that, if they have CLI options. I know it is with astronomer, but it's fine. So I created these folders manually, and I also created this environment file, which is nothing but a value called 50,000, and that's it. Okay, and whatever code we want to write, we simply write the code in the DAGs folder. So let's say I want to create a DAG that looks like this. So what is this DAG? Basically, I am creating a DAG with 3 tasks. This is task number 1, this is task number 2, this is task number 3. And these tasks are like very simple because we just want to see a demo. We are not extracting any data, nothing. These are simply the functions. And I am using a task decorator, which is the new addition, latest addition, where I do not need to create a task. I can simply say task, add the task, and it will create a task for this particular function. Earlier, this was not the case. We had to just mention, hey, this is a task, hey, this is a bash operator, this is a Python operator, this is a SQL operator. No, we are good with that. Then all these 3 tasks are stored in a DAG. Okay, obviously, task number 1, task number 2, task number 3, and this is the order, and this completely is a DAG, right? So same thing here. And then we simply design the dependencies like this: first task, second task, third task. And what is the name of this DAG? Ansh DAG. Why? Because whatever name you will pick for function, it will become your DAG ID. Okay, you can also specify here if I say DAG ID, but it's fine. I do not need to specify any DAG ID because I like keeping function names as my DAG IDs because it makes code more readable. Okay, so now let's try to run this DAG. How we can just run this? First of all, I will run my container for Airflow because all of this code will not be running on my machine. No, will not be running on my machine. It will be running on Docker, and Docker port 8080 will be connected to my local machine's port, and then I can just interact with the UI. That's it. It is not running on my machine. Docker is running on my machine, but Airflow server is running on the Docker container. Okay, so let's try to create Docker. So I will simply say Docker compose up -d because I want to run it in the detached mode. So it is currently creating all these images, as you can see. Created. It will take, I think, hardly 1 to 2, not even 1 to 2 minutes, like just a few seconds. And once all the images are up and running, then we can simply go to the local server 8080 just to see the UI of our DAG. let's see. And I can also see the progress of my container. Okay, these three are turned on, these are pending. Okay, Redis is turned on, Postgres is turned on, Airflow init is turned on. Now API server is being turned on. Okay, because we need API server. And let's see, it should not take much. Yeah, almost all the things are done. Okay. $64, 65 seconds. Okay, perfect. So now it is turned on. Now if I go to my local host 8080, and this is basically the Airflow UI that you are seeing. Okay, so quick overview, this is the home page where you see almost everything. And if you click on DAGs, you will see all the DAGs that we have. You will say, Ansh Lamba, when did you create 83 DAGs? I didn't create 83 DAGs. We get almost so many DAGs by default. So by default, we get 81 DAGs. Okay, I have two more DAGs as you can see in my VS Code. This is the one. This is called Ansh tag, and this is the second one. Okay, with the same name, but it's fine. Okay, these are the assets. If we have any kind of database connected, usually we just connect Postgre. Okay, then admin, then security, and all those things. So let's simply go to DAGs. If I search my DAG name, which is Ansh tag, so this is a DAG. If I click here, you will see the graph. See, this is the graph. This is the DAG. First task, second task, third task. Makes sense? This is just a graph. See, this is just a graph. If I want to run this, I can click on trigger, and what will happen? It will simply start running my DAG. Okay, so first of all, this task is running, as you can see, running, then running, success. So all the three tasks are completed. Make sense? So that's how you create a DAG in Airflow. You can literally automate anything. You can just save your code in your Python function and you can just simply automate it. Make sense? Usually we simply orchestrate using Apache Airflow. We do not process any data. We do not write any Python transformations. No. We simply orchestrate it. Like we want to run this, we want to run this, we want to run that. And all the transformation, all the real coding, like processing, will be in the dedicated Python files. But with the functions, we can simply run it and pull it, and that's it. It is just an orchestration tool. Make sense? This is all about Apache Airflow. Okay, makes sense. So that's how you can just work with Apache Airflow. Now, you are familiar with Apache Airflow as well. Now I want to talk about some cloud big data engineering tools and technologies and basically tech stacks that we follow. Because then you will be having a clear picture. Like all these technologies are there which are open source, but there are so many cloud big data engineering technologies that you should be aware of. I want to start with Azure tech stack because Azure tech stack is currently like very much in demand. And let me just display all the Azure tech stack which are in demand and why that tech stack is used and what is the purpose for that and all those things. And now you will be able to understand all those things, right? So let's try to first of all uncover Azure big data engineering tech stack, and then we can just simply go with AWS and GCP. And then we will simply look at one or two more things about big data, and that's all. Let's see. So this is like one of the end-to-end Azure data engineering project that I have built. I have made a lot of Azure data engineering projects. So I can literally show you one of the examples that you can literally relate to it, like what actually happens end-to-end under the hood. Okay, and you will actually see like how this tech stack is working. Make sense? So first of all, let's say in our project, this is our source. Okay, this is our what? This is our source. Okay, in this source, we have SQL database, we have GitHub APIs, and this API can be literally anything, and SQL sources can be like of any SQL server. Make sense? Then what we do, we simply extract this data and we dump this data in the bronze layer. As you can see the bronze medal here, right? So how we extract the data? How? We extract this data in Azure using something called as Azure Data Factory. This is the Azure Data Factory. Okay. Make sense? Azure Data Factory. Now, what is Azure Data Factory? We just talked about Apache Airflow. Yes, Azure Data Factory is the same thing but low no code solution. So let's say you want to orchestrate everything, right? You want to just build that DAG, but you do not want to write the code. You just want to use drag and drop UI features. You can use Azure Data Factory. Yes. So Azure provides you low no code solution for orchestration. And it is one of the most popular data orchestration and data, you can say, building data pipelines, like most popular. Make sense? Then this is your data lake, and you dump your data in the data lake. Then you read this data from the bronze layer and you apply the transformation, okay, and you create something called as silver layer. And what is the technology that you use? What is that technology? The technology is, you are aware of this, Databricks. Because obviously, in order to process your big data, you need to run Apache Spark, right? You need to run PySpark. You need to run that, right? We just read about this. So in order to run your PySpark is basically the Python plus Apache Spark. It is a Python library. It is just Spark, but yeah, Python library for it. So if you just want to run PySpark coding, you need to use Databricks. And yes, you can use Databricks with Azure very easily, and you can process your data and you can just write your Spark coding very easily. Make sense? And you transform this data and you, let's say, dump this data into the silver layer. Then this silver layer is connected to something called as warehouse, right? When we just model our data. So for modeling, we use something called as Synapse Analytics in Azure. Synapse Analytics. Okay, this is a solution that we have for data warehousing, and this is the logo for it, Azure Synapse Analytics. Make sense? And then for security, we use Entra ID. For storing the secrets, we use Key Vault. For CI/CD, we use Azure DevOps. So this is a complete Azure Big Data Engineering tech stack that we use in a day-to-day activity. And the good thing is, all the dedicated courses are available for each technology, for Data Factory, for Databricks, for Azure DevOps, for everything, for literally everything, for CI/CD, everything. But you need to aware that, okay, these technologies are used to perform these tasks. You need to be aware of this thing, right? Make sense? Very good. So this is all about your Azure tech stack. Similarly, we have AWS tech stack as well. We have GCP tech stack as well. I'm not a big fan of GCP. I have not used much GCP, but for AWS, because AWS is very popular. So let me just show you the AWS part as well. So let's say AWS Data Engineering Tech Stack. Let's see if we have anything in the official documentation. Let's try to see. Do we have anything? Oh, AWS. So. Let me just check their website. Professional certification, hands-on. Bro, at least put a good architecture so that people can be excited. Right now, like, products do not know how to market. AWS. Maybe this is the one. Data engineering. PDF platform data architecture. Let me search AWS Data Engineer Project Architecture. Is this official AWS website? Oh yeah, okay. So they have this cool image. So we can just use this. So let's say, and first of all, let me just make you aware for one thing. If you are using AWS is amazing cloud provider. I know that. Second thing is AWS, with AWS, you will be using a lot of open source frameworks as well. But with Azure, you will not be using many open source frameworks. Make sense? So this is like one difference that I personally feel. So let's say it starts with, let's say, GitLab. Okay. So let's say you are simply using AWS CDK, which is deploy infrastructure, nothing else. Okay. So let's say you want to, and I think this is not a very good example, to be honest. Uh, okay. Yeah, that is a good one. So we can just talk about this thing. So as you are just working with data infrastructure, so basically these are one of the most popular services provided by AWS. Amazon S3. Amazon S3 is just the famous or basically catchy name for data lake. We just call it as S3 bucket. We just call it as S3 bucket. So in Azure, we call it as data lake. We call it as, let's say, Azure Data Lake storage. Okay. But here we just call it as S3. Makes sense. Then in Azure, we have Azure Synapse Analytics. In AWS, we have Amazon Redshift. Okay. And similarly, there are like so many alternatives to each technology. So the moral of the story is, I'm not just making you aware of each and every technology in AWS. No, I just want to make you aware about only one thing, that each cloud provider is different, I know, but their underlying goal is the same. For example, for data lake, Azure will be having Azure Data Lake storage, AWS will be having S3, Azure will be having Azure Synapse Analytics for data warehousing, AWS will be having Amazon Redshift. So services will be different, but the goal of that service will be exactly the same. So you do not need to worry about that. So it is a very good saying that whenever you just want to start your cloud journey, start with one. Let's say you pick Azure. Now in future, if you just want to become a master in AWS data engineering as well, it will be very easy for you. Reason is very simple, because you already know the technologies, you already know the goals, you already know the intent and architecture of each technology. In other cloud provider, it is just the same, but a different features and different UI, that's it. 80% of the things will be exactly the same. So this is a saying that I am totally I just totally agree. Okay, you can literally start your cloud journey with any cloud provider, Azure, GCP, AWS. Currently, I know Azure is booming, so you can simply go to Azure, go with Azure. Okay, and for Azure, you will find almost all the detailed courses on my channel, because I love Azure. I work with Azure a lot. So, and again, it is booming. So you need to first of all master one cloud, all the technologies of that, then you can easily shift or easily learn any other cloud technology. It's not a big deal. Make sense? Similarly, you will see the GCP as well. Okay, you will see GCP as well. Let's say this is a GCP, Google Cloud Platform. Google Cloud Platform is actually very new as compared to other two, Azure and AWS. So this is the architecture that they have. So one technology is very popular in GCP. It's called PubSub model. For it's like publisher and subscriber model. Then they have something called as Google Cloud Storage. It is called GCS instead of calling it as S3 buckets or data lake. For data warehousing, they have a very popular technology called BigQuery. It is very popular. It is even more popular than Redshift. Okay, it is better than Synapse Analytics. That's true. Yes. So it is like one of the most popular technologies that Google is like known for. BigQuery. So there are like so many cool things that you can just explore. Okay, but I would just recommend stick to one cloud for at least 1 year. Do the strong hands-on, then just switch to the other one. Do not just like jumping between clouds like within 1 to 2 months. No, at least spend 1 year and master one cloud, then jump to the other one, because you need to gain end-to-end understanding in at least one cloud. Then you need to jump, because people do not add this line. I add this line that you need to first master one cloud, then jump to the other one. Make sense? Very good. And if you just want to get started your Azure journey, it is very easy. How? Because Azure provides you a free account that you can just create, and you can literally start exploring your Azure services. You get free trial for 30 days. Okay, and how to get started with it? You can simply go to Google, simply search Azure free account, and wow, see, this is the thing. I'm searching Azure free account and see what I'm getting in return. Slow claps for the search engine and search engine optimization. So I will simply click on create your Azure free account or pay as you go, and then I can simply click on try Azure for free. If I click here, I just need to sign in and my Azure account will be there, and I can literally, so it is just showing that you already have one, so it is fine because I already have one. So you can literally create your free account and you can start exploring and learning Azure. You do not need to worry because everything is there in the courses as well, from account creation to learning all those things. Make sense? Now you have some understanding about cloud as well, and do not worry, I will just show you my cloud account as well because I know you are very excited to see that. So let me just quickly show you. If I go to portal.azure.com, so this is basically my Azure account, okay, that I use to build projects and to do so many things. So this is basically the UI, and I love its UI. It's very catchy, and I love this blue theme, so it's amazing. So these are basically the services that we use within Azure. Okay. So remember we were talking about Data Factory, Databricks, Enter ID, all the things are there. Okay. And here you can see all the popular services such as storage accounts, virtual machines, everything. Okay. I can even show you Synapse Analytics. If I search Synapse Analytics, you will see Azure Synapse Analytics, and I can just even create Azure Synapse Analytics within few clicks. So these are all the services that we have created, and I have covered literally every service in my courses. You can simply check it out. I will just guide you through that as well, but I just wanted to show you this UI because the thing is, see, you just need the initial 10 to 15 minutes of familiarity before learning something, because when you have that familiarity with that particular tool, or let's say that particular technology, you're you are ready to learn it. But if you are not familiar with the technology, those 15 minutes are not there. You will be very reluctant. Hey, should I learn Azure? Hey, should I learn cloud? Let's delay. But now I have shown you this UI. Now I am 99% sure that you will be like, hey, I want to learn this, because now you are familiar with the UI. This is the psychology. Okay. I'm not a psychology master, but just trying to help you as much as I can. So now you will be like, hey, let's learn this. This is the thing. And this is the whole agenda of this big data engineering masterclass, where you are already familiar with almost everything. Now you will learn everything. I'm so sure. So sure. Make sense? Now I want to talk about one last topic of this particular section, basically of this particular video. It is called real-time data analytics, or basically real-time data processing, which is becoming very popular nowadays. And let's talk about this. Okay, let's talk about this. Let me just open a new window and let's talk about it. Basically, what is real-time data analytics? What do you think? Why people are talking a lot about real-time data? And why people are talking about Apache Kafka, which is very popular nowadays? And it is not just even popular in data engineering. It is so much popular in the software engineering side as well. It's all about real-time data, because now the velocity of the data is so quick that they cannot wait to process the data. They have to process the data right away. That is why we have to include some frameworks which can provide us some support to process the data and store the data immediately. So if we talk about Apache Kafka, what is that? Let's try to explore their website. Okay, Apache Kafka. By the way, if you are not aware about Apache Kafka, amazing, you can say, development. And do you know who actually developed Apache Kafka? I'm a big fan of her. It's Neha Narkhede. I'm a big fan of her, and she's in US. She has founded Confluent as well, which is again the managed service built on top of Apache Kafka. She used to work in LinkedIn, and there she just figured out this problem and she solved it with her team. And then she just found she became the founder of Confluent, and now she has, I think, one more startup which is booming. I'm a big fan of her. Okay. Oh, it is here as well. Developer Neha Narkhede. I'm a big fan of her. So yeah. So let's try to see like what is Apache Kafka. So basically they are saying more than 80% of all Fortune 100 companies trust and use Kafka because Kafka is the backbone of real-time data processing and data, not processing, by the way, data you can say, not storage as well. Like it's a framework that helps you to just work with real-time data. Okay, so let's try to see the introduction. What is Apache Kafka, blah, blah, blah. First of all, it is saying what is event streaming? Event streaming is the digital equivalent of the human body's central nervous system. Wow. It is a technological foundation of always on world where business are increasingly software defined. Very well done. We are not here to listen to your business pitch. Okay. What can I use event streaming for? Literally for everything. Okay. Literally for everything. Apache Kafka, this is the main point. Apache Kafka is an event streaming platform. And I was just about to say this. What does that mean? Kafka basically combines three capabilities: pub, sub, publish and subscribe. Basically, producer and consumer. Basically, write and read, whatever you can say. Okay. Publish and subscribe stream of events, including continuous import, export of data from other system. For example, let's say you have you have a device, or you have an IoT device. IoT device can be sensors, thermostats, and all those things, which are like literally releasing the data, generating the data in the real time. Now you want a solution. You want a solution which can actually handle these events because every data which is being generated is an event, right? Yes, is an event. So if we just want to store the streams of events reliably and for as long as we want, we can use Apache Kafka. Let's say I want to use basically a solution which can store my events for 2 hours, for 3 hours, for 2 days, 3 days, or basically on the number of events. So everything I can just configure. Make sense? And to process streams of events as they occur or retrospectively. That means if the event is just appeared, we can process it right away, or we can process it maybe later on. Make sense? So now all this functionality is provided in a distributed, highly scalable, elastic, fault tolerant and secure manner. This is your Kafka. This is your Kafka. Make sense? Make sense? Okay. Make sense. Like obviously we're not discussing about Kafka in detail, but just to feel like. So basically there's a device which is generating the data and you need a solution to store that data. That's where Apache Kafka comes into the picture. And do you know what? We have an alternative to Apache Kafka in Azure. It is called Events Hub. Let me just show you. Apache Kafka alternative, or let's say alternatives in Azure. See, Azure Event Hubs. Azure Event Hubs is almost similar to Apache Kafka, where it captures the messages, it captures the events, and events can be anything. It can be logs being generated from a system, literally anything. So it simply stores the messages in a queue, and we can use that, basically that information in a real-time manner. Okay, makes sense. And we also have one service called Confluent Cloud on Azure, and I think this will be a managed service, I'm so sure. Let's actually explore. If I search Confluent, yes, see, Confluent Kafka. If I click here, I can literally create no Apache Kafka and Apache Flink on Confluent Cloud and Azure native IS services to display. So I can click on create and I can create a managed instance. Make sense? Make sense? But there is a different service which does not even use Apache Kafka. It's called Event Hubs. If I search Event Hubs, so this is your Event Hubs. What this does, basically what this will do, this will simply create a similar thing where I don't need to manage anything, I don't need to write any code. I will simply create my event hub, okay, and I will simply say, hey, I want to store all my messages from my source, basically publisher, okay, makes sense, publisher, and it will simply store all the events in a queue. So that is the real time, basically, events storage. Now you will say, Ansh, Lamba, real time event storage or real time data storage is fine, but how we can process this data in the real time? Because there are two parts of real time data. One is data storage in a real time manner. Second is processing the data. How we can just process the data in the real time? There are two things. First of all, we can use Apache Spark. What? We can use Apache Spark for that? Yes. So there's a concept in Spark called Spark structured streaming. So this Spark structured streaming allows us to process the data in the real time. Okay, in the real time, literally real time. So this is like handled by Spark. So in short, we can say Apache Spark takes care of your processing, including real-time processing as well. Make sense? Very good. Is there any other solution that we can use other than Apache Spark? Yes. It is called Apache Flink. Okay. This is a newer, I wouldn't say newer. Apache Flink. Okay. It is for your data streaming, real-time streaming. Then these are like open source, right? There's a managed service as well in Azure. It's called Stream Analytics. Stream Analytics. So if I click on Stream Analytics, I can simply create Stream Analytics jobs. What it does, it simply takes the data from the event hubs and it will simply input the data, process it, and it will write the data to somewhere else. Similar to Apache Spark structure streaming. And it's an amazing feature within Azure to process the data in the real time. Make sense? Make sense? Do not feel like very overwhelmed, because you need to first of all be familiar with these jargons. Once you are aware of these terms, then you can simply quickly get started with it. It's not a big deal. It's not a big deal. Make sense? I hope it makes sense. Okay, very good. So this was your Big Data Engineer Fundamentals Masterclass. And yes, I want to show you all the links, all the courses, everything. So for that, I have a surprise for you. I have literally spent so much of time to create this, but I was like, let's do it. It would be worth sharing it with others. So I have created this GitHub repo. Okay. This GitHub repo is called as Data Engineer Roadmap. So this data engineering roadmap has everything that you want. Okay, and you can literally click here and you can first of all click on this button. Okay, because I've literally spent so many time to create this. Then you can click on this fork. It is my repo, that is why it is grayed out. In your case, it will be there. Forking a repo means when you just want to create a replica of that repo in your account, so that you will see all the details, all the updates whenever I'm just making the updates in this particular roadmap. So basically what is this roadmap is, it has literally everything. So it has all the resources, all the videos, all the courses, everything is for free. Let's say you want to start everything from scratch and you do not even know Python and SQL. You can simply go here, click on this video. So basically these are the links. Okay. If I click here, this will be a video. See? Make sense? Then SQL. Let's say this is completed. Okay. Then you are simply learning fundamentals of data engineering. It is done. Then you want to learn data warehousing. Completed. Then you want to learn data modeling. Completed. Then go to module 3, which is Apache Spark. So this is the complete course for Apache Spark. This is the complete course for PySpark. This is the complete course for PySpark like real-time scenarios. Then GitHub. Then Azure Data Engineering Tech Stack. This will help you master all the things. Fundamentals, Data Factory, and then Data Factory Advanced course, and then Synapse Analytics, then Databricks. All the Databricks courses are here from, like, in short, every particular chapter module is here that you need to become a complete data engineer, big data engineer this year. And this particular roadmap has all the resources listed out here. Okay, all are free, literally 100% free. So you can literally go here and just watch each and every video. If not each and every video, just pick your modules that you want to learn. Simple. And just one pro tip, if you want to master a specific topic, simply search that topic on Google or YouTube and just add Ansh Lamba after that. You will see the video, because I have literally created videos on almost every topic. Make sense? I hope now you can literally find all the resources, and I hope now you have that fundamentals baseline ready to explore more and more things. I hope so. So very well done. You have completed this masterclass, and buckle up and just try to become a data engineer with all of these resources. And just click on the video coming on the screen right now, and I will see you there. Happy learning.